Africa is a very specific continent. It's known by its a huge biodiversity, but unfortunately, it's threatened by a lot of things, such as deforestation, pollution, human-induced climate change, and many, many other things. But in general, we have very big lack of research infrastructure because we don't have enough laboratories equipped with solutions, with systems, and with technologies in order to overcome those problems. Across Africa, agriculture and biodiversity is facing, as I said, interconnected challenges. So here I put some of them, or all of them, I think. First of all, we have a very big lack of research, as I said. We don't have enough researchers and engineers, and also head of laboratories which are trained well on technologies, including Illumina, or especially for Illumina. And here we have another problem, which is the government. We don't have programs for overcome those problems. And also we have the habitat loss, because it's a very growing issue, and the expansion of one culture, what we call monoculture. Here, intense farming also reduces the natural habitat, and the genetic diversity, which are very essential for healthy ecosystems. Another challenge that we are facing, or that agrigenomics is facing, are the policies. The policies is very weak or very fragmented, and the expansion, as I said, it makes very difficult to apply programs for farming. Also, the genetic monitoring is still limited, and only few countries have what we call seed banks or gene banks. And the genomic data are also often missing to support the long-term preservation. And finally, the climate change and the soil degradation. It's a threat, and our crops and our ecosystem, especially Morocco, for example. It's known by diverse crops. We have livestock also. So here, all those challenges must be overcome by applying the technologies. We have the genomic technologies that we can better understand these challenges, as I said, protect our biodiversity, and make agriculture much better across Africa, and especially in Morocco. So what is the role of genomics here? When we can see this slide, we can think about milk, we can think about food, and when we are taking our food, we often think about farmers, who are really working so hard behind. But agriculture affects more than what we think or what we eat every single day. And that's why here the genomics plays such an important and crucial role. It helps to improve productivity, protect our diversity, and also increase the yields. By understanding the genetic of plants and animals, genomics also support the long-term food security, making agriculture more sustainable for the future generations. Today, we have an amazing tools in order to do all this work. We have a big opportunities to use the power of the genomics to make life much better and safer. Food, as I said, is very essential for humankind, and genomics helps us to make it, as I said, safer and more sustainable. And thanks to the genomics, because scientists here can study this biodiversity, protect endangered species, and also preserve ecosystems. And finally, to develop the sustainable farming to face the climate change and all other challenges. It's a very powerful tool to build a better and more secure future for our planet, a planet which should be hunger-free. As I said, genomics play a key role in protecting biodiversity and supporting sustainability. But now let's have a look more closely at how agriculture or agricultural genomics or agri-genomics in helping actually drive sustainable productivity and providing real solutions to the growing challenges of feeding our expanding global populations. As you know, plants have a very big complex genome, and genomics here help scientists to understand much better to improve crops. With the world's population growing fast and the climate changing, it's more important to protect our food security, and sequencing will help us actually to do this. Genomics also helps in as a study for bacteria, viruses, fungi, which affect our plants and our animals. So farmers can keep their crops and their herds healthy and produce good and better food. So today's agriculture researchers can use those tools. We have NGS technologies and microarray technologies. The microarray and the next generation sequencing by SBS are very useful for studying various aspects of plant and animal genomics, including the genotype, gene expression and regulation, and epigenetics. These approaches offer the throughput, sensitivity, and precision needed to evaluate genetic markers and discover new ones associated with traits or diseases. Excuse me. So plant and animal sequencing with NGS will give us a detailed look at the genetic differences between or that affect traits like growth or disease resistance. It helps scientists to discover new genetic markers and can be more affordable for small projects. Microarrays, on the other hand, are great for large-scale projects or studies. They will allow researchers to screen many samples at the same time and use genetic data to guide breeding and selection. While Illumina's, with Illumina's microarray, we can quickly analyze thousands of known markers and even find new links between genes and important traits. So these technologies will open the door to, for the researchers and innovation in order to make strong partnerships with us. This partnership is very important in terms of to support African biodiversity and agriculture. We believe that scientific events and marketing support, we can achieve our goal of capacity of building. And it's not just about solving problems, but also about fueling creativity, innovation, and motivation for a better and more sustainable future for our beautiful country and beautiful continent, which is Africa. And we have very strong partnerships with many institutions and universities across Morocco on three main applications. We have agri-genomics, we have oncology, and infectious diseases. And we have a very big team behind, of course. We have Illumina team and Megaflex team. With Illumina team, we have Dr. Chatou Hamza. We have Lydia Hatcheras, that I thank a lot because they are always here to support us, to support our customers. Thank you so much. We have Megaflex team. We have our business unit manager, Dr. Aliani Issa, which is here present with us. We have our NGS sales executive, Amin Armish, and me. And also we have technical and field application scientists that are trained and they can support at any time our customers, even during weekends and holidays. So we are here, Megaflex and Illumina team, for you. Our time, it's not something that we can discuss about, that we do this because we love doing this. We love support our customers, and you are welcome for any question. You can reach wherever you want. Thank you so much.
So now we will move to the question and answer section. So I will invite Dr. Hamza Chatou to join us for the QI section. Sorry, session. So first of all, I would like to thank you again for your insightful presentations about how Illumina and also Megaflex through Illumina can help research, young researcher and experimental researcher in answering basic fundamental questions about biodiversity and how we can encourage genomic studies. So I will give the floor to the audience if there is any question. We have one there.
Yeah, we can hear. Yeah.
My question is actually very simple, and it's for both of y'all. Where is Illumina on long read technology or product line for the moment?
Great question. Thank you very much. Yeah, it's true that we've been mainly known for short read sequencing, and there is also innovation in terms of long read sequencing by other providers, but Illumina also is working on long read solutions. So we have announced a solution called Constellation. I don't know if you have heard about this solution. So basically, with this solution, you don't need to invest in other sequencers in order to have this long read information. The other advantage is that you simply just load your DNA on the flow cell without any library preparation done outside the instrument. And then the DNA basically will just go on the flow cell, and then it will be sequenced, and then we will be able to map long reads of these fragments and give you the insights as with the long read classical technology. So yes, we have worked on that, and now we are able to propose to our customers these long read solutions as well.
So it's just skipping fragmentation. Is that what you're saying?
Well, there will be some fragmentation, but it will be done on the flow cell. But the advantage is that we are able to map all the fragments on the flow cells and reconstitute the long fragment afterwards.
Do you have any idea how does it compare to PacBio for now?
So far, the first results are quite promising, and in some cases, we can even get insightful information that's sometimes even difficult to get with other technologies. So it's promising, and I think once it will be available quite soon, very soon. And we look forward to have the first data from the customers.
Thank you.
Thank you.
You're welcome.
Any other question? So I do have one, please. So it's related to these new innovations that you spoke about. So we know that with NGS technologies, it is always costly. And I don't know if this new technologies or new innovation will be cost effective and will be, it will be easy to be provided even when we have low budget. As you know, for some projects, we don't have sufficient amount to acquire such technologies.
Great question, thank you. It's true that cost of sequencing has been quite a challenge a few years ago. And at Illumina, we've been multiplying efforts in order to get down this cost of sequencing and get it more accessible for our customers. And we successfully reached that goal. For instance, the first human whole genome sequenced costs hundreds of thousands of dollars. Today, we are able to offer a cost of sequencing of human genome less than 300 euros or dollars. So it's a huge effort that was made, and we continue to make these efforts at Illumina. But now what we can see is that reflections are moving from cost per sequencing to cost per sample. And this is very important because, as I mentioned, the genomics or sequencing workflow, next generation sequencing workflow is not only sequencing. You have library prep, you have, of course, sequencing, and that you have also bioinformatics solution. And at Illumina, we are now focusing on getting a cost per sample accessible to our customers. So, of course, in the innovation, our innovation solutions, we are working on that to make sure that our new technology and solution still remain accessible to our customers.
Okay, thank you so much. Is there any other question?
Yeah, I think we have a question online.
Yeah.
Yeah, shall I go ahead?
Yes, please.
Yeah, my name is Tengod Ebenezer. Dr. Hamza, I think that's an interesting one to hear. There's a long read coming from Illumina. So, and you mentioned you just load the sample on a flow cell. And I think my question kind of relates with the previous person's question about fragmentation. So, but my own is kind of more upstream. So does it mean there is no pre-analytical step that would happen, or you just load, it works directly on the sample itself? Essentially, that's one question. Two is, has this been, or is this being used already in animals and plants, especially non-human samples? Because we, in the African BioGenome Project, tend to focus more on biodiversity, agriculture, and things that are non-human. So it would be nice to see how, how that has performed in the non-human space.
Great question. Thank you very much. So let's start with the first one. The first one in pre-analytical steps. So basically, if you're talking about library preparation, there is no library preparation with this new technology, constellation technology. You just need to make sure to have extracted DNA, long fragment extracted DNA, and from there you can load on the instrument. Second question is regarding the application downstream, I mean, if it's on human or on other species. For now, the technology has been developed on human samples. I talk under the control of our genomics specialist, but it will be, I think, extended to other species in the future, I guess. So far, the only information we have, it's available on human samples, but knowing Illumina, knowing the efforts that we do on innovation and the need and the demand that we are seeing in the field, I think maybe, or I guess, it will be extended to other applications in the future. So yeah, I hope I answered your questions.
Yeah, that's fine. Thank you.
You're welcome.
There are some questions online. There's two so far. The first one, I think, is general to the panel that goes, it's from Tedesi Alegen, I guess. Most of us young researchers, there's a problem in sequencing in terms of the way we get it, financing, etc. How can we solve it?
Could you please repeat the question?
No problem.
Yeah.
So the question is, most of us young research, there is a main problem in terms of sequencing, in terms of how we can attain the technology and finance it. How can we solve this problem?
You mean, if I understand correctly, the question is about financing sequencing, right?
Yes, financing sequencing and attaining sequencing technologies.
Well, I don't know if I have the answer to this question. I mean, in research, I don't know how it works in Africa, but in order to finance research projects, I don't know if there is any grants or any other solutions. But in terms, if it's regarding financing equipment in research, I don't know, maybe you can, our channel partners can offer some flexible solutions for payment or any solution of that kind. But yeah, I don't know. Honestly, I don't have a clear answer to this question.
All right, thank you.
Yeah,
And
you're
there's another question from Muhammad Mustafa that goes, I would like to know if we want to perform analysis with microarray, do we have to go through NGS or can it be done independently of NGS?
If we would like to do analysis with microarrays, what's the...
Can it be done independently of NGS technologies?
Of course, of course. So microarray solutions, they have their own softwares and solutions for analysis. And it's completely different technology from next generation sequencing. So we have at Illumina, we can provide analysis solutions and bioinformatics solution for both sequencing and microarrays, but there are different solutions. Yes.
And there is one more. It's a very direct question. How do we in West Africa access the services offered by Illumina?
How can we access in Africa? What's the next, please?
How can Illumina services be accessed in West Africa?
Okay, so if you in Africa we operate.
He's mentioned in West Africa.
West Africa. So yes, we have channel partners in West Africa. You can go back to the slide where I talked about the list of all our channel partners. I think in West Africa it's SSM and also ISN. They can certainly help you to access our technology in West Africa. So keep in touch with them or with us, and we can put you in touch with our distributors and partners to answer your questions and to empower you with our solutions.
I think that's we will close the discussion. So thank you so much, Dr. Shtuh and Dr. Tamimi, for this outstanding presentation and rich discussion. I hope to see you in the next edition, if there is another edition of the AfricaBP. So with that, I will ask the audience to join us to the coffee break, and we will resume in 10 minutes. In 10 minutes. For the next presentations.
Thank you very much again for your invitation. Thank you.
Thank you very much.
BGI Genomics is a leading global provider of a wide variety of omics services, covering genomic sequencing, mass spectrometry, synthetic biology, bioinformatics, and biodata management solutions. We are relentlessly committed to providing the highest quality and reliability of services. In particular, our unique Dr. Tom Multi-Omics interactive analysis platform has already supported countless researchers to publish papers in some of the world's leading journals. We remain dedicated to advancing genomic discovery and leveraging our world-leading experience to help our partners. We are committed to driving discovery even further. BGI Genomics. We sequence, you discover.
Well, I can't believe it's been 10 years since Nanopore Biotech West Africa opened its door for the business here in Nigeria and in the large West African region. And for over a decade now, we've been at the forefront of driving genomics and life science across the region.
It's been 10 years of excellence. It's been 10 years of hard work. I remember when I joined the company, we started from a very humble space within IITA.
It feels just like yesterday. I joined in Kaba in 2018. Since then, there has been significant growth.
With Central Africa being the most recent region
to have a representation for Inkaba Biotech. Our creation and existence has benefited considerably from experience and mentorship of Inkaba Biotech West Africa Limited, Ibadan, Nigeria.
Reflecting on the last 10 years showcases hard work, diligence, tenacity, excellent leadership, and help from God. At Inkaba Biotech Limited, our core values are quality, customer focus, integrity, teamwork, and others.
From groundbreaking research to empowering our team and customers through training and development, we've built a culture of continuous growth while staying true to our mission to facilitate life science research in West and Central Africa.
My name is Emma. Customer service representative from PacBio West Africa Limited, Ghana.
My name is Yusuf, the manager for PacBio Ghana.
Good morning. I am Mamadou Dabo from Mali.
I extend our warmest congratulations to the 10th anniversary of PacBio Nigeria branch.
Congratulations to our counterparts and our colleagues in PacBio Nigeria for their 10th anniversary.
Happy 10th anniversary year to all Inkaba Biotech staff in West Africa region.
Happy 10th years anniversary to all of my colleagues from Nigeria, Cameroon, Benin, Mali, and Senegal. We are the West Africa team.
Having provided sequencing services in Nigeria for about 4 years now, we've come to understand the needs of the research space, and as such, we see the need for improvement. And in the future, we're looking to take up a bit more responsibility in this space.
We've really achieved a lot. There's still a lot more to achieve. I strongly believe that IBOA, as a company in Inkaba Biotech West Africa, has really positioned itself to be a major driver that will facilitate the growth of the biotech industry across West Africa.
We are not only celebrating the past, but looking to an even brighter future ahead. We will continue to collaborate, innovate, and make meaningful contributions to Africa and the world at large. Here's to 10 incredible years and an exciting journey ahead. Happy anniversary, Inkaba Biotech West Africa.
Long live Inkaba.
This is to many more years of growth and positive impact to science across Africa. Happy 10th anniversary, Inkaba Biotech West Africa. Cheers.
As we look ahead, Inkaba Biotech remains committed to driving innovation and technological advancements in the life science and genomic space. We intend to do this by investing heavily in the latest equipment and sequencing technologies, empowering scientists across the continent so they can continue to do the amazing work they do. And very importantly, we also plan to serve new regions within the territory by expanding our tentacles into countries where we currently do not have a presence. So I hope you can join us in creating this amazing journey.
Despite the fact that resources are limited in Africa, the team has steadily developed an enterprise, including the setup of a genome lab that provides summary sequencing services in Ibadan. And we look forward to add other genomic services like next generation sequencing using biosequencers like we do here in Pretoria. As Inkaba Biotech, we aim to contribute within our means to the science and economic development on the African continent, a continent that has a vast diversity and needs so much more equality. We have created more than 40 jobs at our offices in Nigeria, Ghana, and Senegal, and this will continue as the need for application in life sciences and diagnostic develop in West Africa.
BGI Genomics is a leading global provider of a wide variety of omics services, covering genomic sequencing, mass spectrometry, synthetic biology, bioinformatics, and biodata management solutions. We are relentlessly committed to providing the highest quality and reliability of services. In particular, our unique Dr. Tom Multi-Omics interactive analysis platform has already supported countless researchers to publish papers in some of the world's leading journals. We remain dedicated to advancing genomic discovery and leveraging our world-leading experience to help our partners. We are committed to driving discovery even further. BGI Genomics. We sequence, you discover.
Well, I can't believe it's been 10 years since Illumina Biotech West Africa opened its door for business here in Nigeria and in the large West African region. And for over a decade now, we've been at the forefront of driving genomics and life science across the region.
It's been 10 years of excellence. It's been 10 years of hard work. I remember when I joined the company, we started from a very humble space within high IT.
It feels just like yesterday. I joined InCaba in 2018. Since then, there has been significant growth.
With Central Africa being the most recent region to have a representation for InCaba Biotech, our creation and existence has benefited considerably from experience and mentorship of InCaba Biotech West Africa Limited, Ibadan, Nigeria.
Reflecting on the last 10 years showcases hard work, diligence, tenacity, excellent leadership, and help from God. At InCaba Biotech Limited, our core values are quality, customer focus, integrity, teamwork, and all that.
From groundbreaking research to empowering our team and customers through training and development, we've built a culture of continuous growth while staying true to our mission to facilitate life science research in West and Central Africa.
My name is Emma, customer service representative from PacBio West African Limited, Ghana.
My name is Yusuf, the manager for PacBio Ghana.
Good morning, I am Mamadou Dabo from Mali.
I extend our warmest congratulations for the 10th anniversary of PacBio Nigeria branch.
Congratulations to our counterparts and our colleagues in PacBio Biotech Nigeria for their 10th anniversary.
Happy 10th anniversary year to all InCaba Biotech staff in West Africa region.
Happy 10th years anniversary to all of my colleagues from Nigeria, Cameroon, Benin, Mali, and Senegal. We are the West Africa team.
Having provided sequencing services in Nigeria for about 4 years now, we've come to understand the needs of the research space, and as such, we see the need for improvement. And in the future, we're looking to take up a bit more responsibility in this space.
We've really achieved a lot. There's still a lot more to achieve. I strongly believe that IBOA, as a company in BioInformatics West Africa, has really positioned itself to be a major driver that will facilitate the growth of the biotech industry across West Africa.
We are not only celebrating the past, but looking to an even brighter future ahead. We will continue to collaborate, innovate, and make meaningful contributions to Africa and the world at large. Here's to 10 incredible years and an exciting journey ahead. Happy anniversary INCABA BioTech West Africa.
Long live INCABA.
This is to many more years of growth and positive impact to science across Africa. Happy 10th anniversary INCABA BioTech West Africa. Cheers.
As we look ahead, INCABA BioTech remains committed to driving innovation and technological advancements in the life science and genomic space. We intend to do this by investing heavily in the latest equipment and sequencing technologies, empowering scientists across the continent so they can continue to do the amazing work they do. And very importantly, we also plan to serve new regions within the territory by expanding our tentacles into countries where we currently do not have a presence. So I hope you can join us in creating this amazing journey.
Despite the fact that resources are limited in Africa, the team has steadily developed the enterprise, including the setup of a home lab that provides summer sequencing services in Badan. And we look forward to add other genomic services like next generation sequencing using biosequencers like we do here in Pretoria. As INCABA BioTech, we aim to contribute within our means to the science and economic development on the African continent, a continent that has a vast jobs at our offices in Nigeria, Ghana, and Senegal, and this will continue as the need for application in life sciences and diagnostic develop in West Africa.
BGI Genomics is a leading global provider of a wide variety of omics services, covering genomic sequencing, mass spectrometry, synthetic biology, bioinformatics, and biodata management solutions. We are relentlessly committed to providing the highest quality and reliability of services. In particular, our unique Dr. Tom Multi-Omics interactive analysis platform has already supported countless researchers to publish papers in some of the world's leading journals. We remain dedicated to advancing genomic discovery and leveraging our world-leading experience to help our partners. We are committed to driving discovery even further. BGI Genomics. We sequence, you discover.
I can't believe it's been 10 years since Illumina Biotech West Africa opened its door for business here in Nigeria and in the large West African region. And for over a decade now, we've been at the forefront of driving genomics and life science across the region.
It's been 10 years of excellence. It's been 10 years of hard work. I remember when I joined the company, we started from a very humble space within high IT.
It feels just like yesterday. I joined INCABA in 2018. Since then, there has been significant growth.
With Central Africa being the most recent region to have a representation for INCABA Biotech, our creation and existence has benefited considerably from experience and mentorship of INCABA Biotech West Africa Limited, Ibadan, Nigeria.
Reflecting on the last 10 years showcases hard work, diligence, tenacity, excellent leadership, and help from God. At INCABA Biotech Limited, our core values are quality, customer focus, integrity, teamwork, and others.
From groundbreaking research to empowering our team and customers through training and development, we've built a culture of continuous growth while staying true to our mission to facilitate life science research in West and Central Africa.
My name is Emma, customer service representative from PacBio West African Limited, Canada.
My name is Yusuf, the manager for PacBio Ghana.
Good morning, I am Mamadou Dabo from Mali.
I extend our warmest congratulations to the 10th anniversary of PacBio Nigeria branch.
Congratulations to our counterparts and our colleagues in PacBio Nigeria for their 10th anniversary.
Happy 10th anniversary year to all INCABA Biotech staff in West Africa region.
Happy 10th years anniversary to all of my colleagues from Nigeria, Cameroon, Benin, Mali, and Senegal. We are the West Africa team.
Having provided sequencing services in Nigeria for about 4 years now, we've come to understand the needs of the research space, and as such, we see the need for improvement. And in the future, we're looking to take up a bit more responsibility in this space.
We've really achieved a lot. There's still a lot more to achieve. I strongly believe that IBOA, as a company, INCABA Biotech West Africa, has really positioned itself to be a major driver that will facilitate the growth of the biotech industry across West Africa.
We are not only celebrating the past, but looking to an even brighter future ahead. We will continue to collaborate, innovate, and make meaningful contributions to Africa and the world at large. Here's to 10 incredible years and an exciting journey ahead. Happy anniversary, INCABA Biotech West Africa.
Long live INCABA.
This is to many more years of growth and positive impact to science across Africa. Happy 10th anniversary, INCABA Biotech West Africa. Cheers.
As we look ahead, INCABA Biotech remains committed to driving innovation and technological advancements in the life science and genomic space. We intend to do this by investing heavily in
Hello again. So we will resume the second session of today, of this morning, related to genome technologies. And the next presentation will be done by Dr. Fatema Zahra Laidi from PacBio Revio, NGI, Morocco. So Dr. Fatem Zahra-Laidi will present advance in biodiversity research in Northern Africa, the genomic revolution with MGI. So before giving you the floor, so a quick presentation of Dr. Laidi. So she holds a PhD in life science from Nancy, France, and she combines academic expertise with technical know-how to drive MGI genomic platforms for biodiversity and health research in the region. So, Dr. Laidi, the floor is yours.
Je vous remercie. Mon speech sera en français, mais les slides seront en anglais. Tout d'abord, je tiens à remercier... C'est bon? Donc, tout d'abord, je tiens à remercier professeur Bobit pour cette opportunité de représenter aujourd'hui ma biotech et notre solution de génomique MGI. C'est un réel plaisir d'être parmi vous aujourd'hui pour parler de la manière dont les technologies génomiques révolutionnent la recherche sur la biodiversité en Afrique du Nord. Comme vous le savez, notre région a une diversité d'espèces et d'écosystèmes encore largement méconnue, surtout sur le plan génétique. Et grâce aux avancées rapides des technologies de NGS, nous avons désormais la possibilité de comprendre la structure des populations, les mécanismes d'adaptation et contribuer à la préservation des espèces menacées. Aujourd'hui, je vais vous présenter comment les plateformes de séquençage MGI participent à cette révolution génomique en offrant des solutions performantes, accessibles et adaptables et adaptées aux besoins de la recherche en Afrique du Nord. Pardon, je ne sais pas si j'ai... Peut-être pour changer, je ne sais pas si... Je suis désolée. Je présente le MGI. Il fait partie du grand groupe BGI qui est constitué de plusieurs divisions, des divisions à but lucratif et des divisions à but non lucratif. des divisions à but lucratif comme le laboratoire de sous-traitance BGI Genomics, MGI qui est en fait un constructeur des séquenceurs et des solutions de NGS. La division à but non lucratif dans BGI Research, le journal BGI Research, BGI College, le China National Gene Bank, et des divisions qui sont en incubation, la division en incubation comme le BGI Nutrition, les Stomics, pour ce qui est stem cells. Donc, le MGI, ils ont plus de 2277 employés dans le monde entier, dont 30% en recherche et développement. Ils ont 1080 patentes et plus de 5300 séquenceurs installés dans le monde entier et plus de 10 000 publications dans des journaux de facteurs d'impact importants. Donc, le portfolio de MGI, c'est un portfolio riche. Donc, nous avons le workflow complet de NGS, depuis la préparation de l'échantillon jusqu'à l'extraction des acides nucléiques, la préparation automatique de librairie et aussi les séquenceurs de petite, moyenne et grande cadence, la solution bioinformatique, les solutions aussi de stockage, donc la solution vraiment complète, tout ce qu'il faut pour un laboratoire de NGS. Donc la technologie MGI, donc nous avons la technologie en fait de nanoballs, DNB-seq, pour tout ce qui est short reads, et pour long reads, c'est la technologie Nanopore. Pour le short reads, en fait, la spécificité de MGI, c'est que la préparation de librairie se fait sur un ADN circulaire, donc le gène d'intérêt. Nous procédons à une circularisation de l'ADN et puis l'amplification, elle se fait toujours sur le même brin d'origine, ce qui donne un taux d'erreur minime par rapport à d'autres technologies. Une fois on a les nanoballs constitués, ils sont fixés sur les flow cells et puis par excitation de laser, en fait, on a la détection de nos nucléotides. Une autre technologie, c'est pour notre petit séquenceur portable, le E25, que je vais détailler par la suite. C'est la technologie self-immunosequencing, c'est par réaction chimique. Donc, ce séquenceur ne nécessite pas d'installation et c'est un séquenceur portable qu'on peut utiliser par exemple en terrain. Donc, le output de ce séquenceur va jusqu'à 7,5 gigabytes et c'est utilisé surtout pour le small genome sequencing, pour pathogène fast testing, voilà, RNA sequencing. Donc, c'est surtout pour le small genome. Donc là, c'est un exemple d'utilisation de ce séquenceur dans un laboratoire en camionnette. Donc, le séquençage est stable même à une vitesse de 80 km/h. Donc, les applications de ce séquenceur, je vais surtout me concentrer sur la métagénomique, microbial whole genome sequencing et bactériophage. On peut l'utiliser aussi pour les TP, les formations. On a un kit spécialisé pour l'éducation. Donc, le E25, c'est un séquenceur, petit séquenceur portable qu'on peut utiliser en terrain. Donc, il était déjà utilisé à une altitude de 5200 mètres pour des échantillons de sol et aussi en camionnette. Et il est aussi utilisé, comme je vous ai dit, pour l'éducation, pour les formations et les TP dans certaines universités. Les séquenceurs qui viennent d'après, c'est le G99. C'est un séquenceur plus grand qui peut contenir 2 flow cells et qui peut aller avec la nouvelle flow cell jusqu'à 240 gigabytes. Donc, et il peut faire énormément d'applications. Donc, pour tout ce qui est métagénomique, shotgun, pour voilà, le CSS, dans ce qui concerne surtout l'agriculture. Et il peut faire aussi l'oncologie, donc plusieurs applications dans d'autres domaines. Pardon. Le G400, c'est le séquenceur, le best-seller de MGI, c'est le G400. En fait, avec un output qui peut aller jusqu'à, avec la flow cell large, jusqu'à 540 gigabytes pour des applications de métagénomique, single cell, microbial whole genome sequencing. Et aussi pour le whole genome sequencing, il peut aller jusqu'à 8 échantillons par run. Donc, le G400, comme je vous ai dit, c'est le best-seller de MGI. Donc, il est installé, il y a plus que 2300 articles publiés avec ce séquenceur. Donc là, c'est les témoignages des utilisateurs, dont professeur Wu, et qui l'utilise pour tout ce qui est molecular breeding, pardon, et en South Africa, il est utilisé aussi pour génome de référence pour les plantes et les animaux. Le séquenceur qui vient après, qui vient de sortir, la nouveauté après le G400, en fait, on peut dire c'est la version la plus moderne, c'est le T1+, donc qui est rapide, simple et flexible. Donc, son output peut aller jusqu'à 1,2 terabytes avec un Q40 supérieur à 90%. Tous ces réactifs sont intégrés et il peut contenir aussi 2 flow cells. Donc, il est flexible et on peut faire dans la même flow cell des applications différentes. Donc, multi-applications sur même flow cell. Donc, pour la flow cell qui contient 4 lignes et aussi pour les flow cells qui contiennent 2 lignes. Pardon. Donc, voilà, les flow cells small, medium et large. Donc, on peut faire différentes applications sur la même flow cell pour voilà, économiser le réactif. Et pour travailler aussi différentes applications sur le même workflow. Donc, les applications, c'est aussi le whole genome sequencing, bactérien et aussi whole genome sequencing des animaux, plantes, humains. Donc, il peut aller aussi jusqu'à 8 échantillons par an pour le whole genome sequencing. Et enfin, la série T. Donc, on a le T7 qui peut aller aussi jusqu'à 7 terabytes. Il peut contenir 4 flow cells. C'est surtout utilisé pour les projets de génome de population et pour les méthylations sequencing, pour la protéomics. Et c'est pour vraiment une forte cadence. Après, on a le T20. Le T20, c'est carrément une chambre automatisée avec un robot. Le robot qui fait tout, en fait, pour l'extraction, la préparation de librairies, le séquençage, la bioinformatique, tout est automatisé. Et c'est utilisé dans plusieurs pays pour le projet de génétique de population. Il peut générer jusqu'à 50 000 whole genome sequencing par an et à un prix vraiment très modéré, donc jusqu'à $100 par whole genome sequencing. La série T est utilisée dans plusieurs projets, comme je vous ai dit, de projets de génétique de population, comme le projet de l'Indonésie. Il est aussi utilisé en agriculture, en recherche en agriculture, le T7. On a aussi le T20 qui est utilisé par Eurofins, par plusieurs instituts qui sont connus à l'échelle mondiale. Donc, nous avons quelques témoignages des utilisateurs, comme Dr Almeida de l'INRAE de France, qui a en fait le T7 et qui l'utilise pour le projet de métagénomique, et aussi en Brésil pour le projet de génétique de population. Donc, comme j'ai mentionné au début, MGI, en fait, elle a le short reads, long reads. Donc, le long reads, nous avons deux instruments en fonction des applications. On a le séquenceur G100ER, surtout pour le small genome sequencing. Il peut contenir jusqu'à 4096 protéines nanopores par flow cell et il peut aller jusqu'à 85 gigabytes. Et les applications, c'est le whole genome sequencing microbial, la méthylation et le small genome research. Et après, on a le G400ER avec une capacité encore plus élevée, jusqu'à 30 000 protéines nanopores par flow cell. Et son output peut aller jusqu'à 400 gigabytes. Et les applications, c'est le génome assembly, la métagénomique et le génome resequencing. Donc, la politique de MGI, c'est sec-all, donc avoir le tout en fait, le long reads, le short reads. On a aussi le petit séquenceur, le E25 portable. On a le long reads, le short reads avec différentes capacités, la petite cadence, medium et high output. Donc, sec-all avec plus de données, avec un coût réduit et un débit élevé. Donc, pour les kits de préparation de librairie, en fait, on a pour toute application, pour le microbial, pour le métagénomique, pour les plantes, les animaux, avec des solutions bioinformatiques adaptées à chaque solution. Donc, dont je n'ai pas le temps de détailler, mais c'est en fonction de besoins de chaque recherche et de chaque projet. On a aussi les kits pour l'ARN, pour le RNA. Nous avons aussi le portfolio de l'automation. Donc, l'automation soit pour la préparation d'échantillons, pour les grandes cadences, pour l'extraction des acides nucléiques, pour la préparation de librairies automatisées. C'est en fonction de la cadence. On a même pour la petite cadence 4 échantillons. Et nous avons aussi des solutions personnalisées en fonction du besoin de chercheurs. Donc, pour l'omics, donc MGI, multi-omics, ça couvre de la préparation de librairies, DNA et RNA, la protéomics et jusqu'au stockage des échantillons pour les différentes applications. Donc, on a même la solution pour le stockage en fonction des échantillons. Donc, voilà, stockage, en fait, le gene bank, on a des solutions adaptées en fonction des échantillons, en fonction, en fait, des températures de stockage de chaque échantillon et de projets de recherche de chercheurs, en fait. Donc, pour les applications, en omics, on a en fait l'agriculture, food safety, dont on va se focaliser sur cette présentation, l'environnement aussi et la biodiversité. Donc, nous avons une solution complète pour l'environnement et la biodiversité. MGI a une solution adaptée pour l'environnement, pour la métagénomique, à partir de l'eau, ou soit des sédiments de mer, complète jusqu'à l'analyse bioinformatique, qui est le PIFI, un logiciel adapté pour l'identification des micro-organismes non connus. Et aussi, on a tout ce qui est métabarcodine, le 16S, 18S, ITS, COI et 12S. Donc, avec aussi la solution bioinformatique adaptée, donc qu'on peut utiliser sur le G99 et même sur le petit séquenceur portable, le E25. Donc là, l'utilisation de cette application de l'environnement, elle était sur plusieurs, a été utilisée par l'industrie, par la recherche, en fait, par les chercheurs sur les sédiments de mer et sur l'eau de mer aussi. Alors, pour l'agriculture et le food safety, en fait, l'omics en agriculture, ça touche le molecular breeding, food safety, et les maladies des animaux, des plantes et aussi l'environnement, micro-organismes d'environnement. Donc, pour l'agrigénomique, on a la solution de low pass whole genome en fonction en fait, de capacité qui peut aller jusqu'à 400 000 échantillons par an avec une couverture faible de 1,5. Pour le food safety, nous avons aussi une solution complète avec le logiciel PFI, le Pathogen Fast Identification, et aussi avec le meta-barcoding, ou soit par le whole genome sequencing de la souche bactérienne en elle-même. Et ça, c'est utilisé surtout pour le contrôle de l'aliment. On a aussi l'application d'identification des origines de l'aliment qui se fait par CSS, barcoding. Donc, plusieurs partenaires ont fait confiance à MGI, dont l'INRAE, l'Eurofins. Et pour la solution de l'éducation, je termine par cette solution. En fait, c'est une solution adaptée aux étudiants qui peut être faite sur le petit séquenceur portable E25 pour les TP, pour les formations. Donc, elle est déjà admise dans certaines universités en Chine et aussi en Afrique du Sud. Et pour la solution bioinformatique, nous avons en fait des solutions adaptées pour l'agriculture, soit pour en fait l'environnement, pour l'agriculture breeding et pour la santé publique. Voilà, et je vous remercie pour votre attention.
So thank you so much, Dr. Laidi, for this interesting presentation about MGI instruments and technologies at the service of science and genomic studies. So now we will move to our next speaker, which is Mrs. Shaima Abdoun from STL, Middle East and Africa. So she will discuss sustainability meets innovation in the genomic workflow ecosystem. So she's a biomedical engineer with over 14 years of experience, and she focuses on innovative and sustainable genomics workflows that help institutions to integrate advanced technology in an efficient way. So the floor is yours, Mrs. Abdoun.
Okay. Okay, where is the
this next
laser?
previous laser? It's this one.
Okay, thank you. So, hello, good morning, everyone. Today, I'm gonna speak about why actually sustainability, why it's very important to know that sustainability is essential in the business right now. and how it can be an opportunity for innovation and growth. With that, I would like to introduce myself. My name is Shaima Abdoun. I'm working with Eppendorf as a regional sales manager responsible for Middle East and Africa. Today, my title of the presentation, it will be about sustainability meets innovation in the genomics workflow ecosystem. I know that many of you knows Eppendorf already, but whoever doesn't know Eppendorf well, Eppendorf is a German company, a German manufacturer. It was founded in 1945 in Hamburg by Dr. Heinrich Nettler and Dr. Hans Hilns as a workshop for medical instruments. Still, until today, it's 100% owned by those two families till today. And we are there in the market for almost, I would say now, 80 years. Our main focus was on value creation, innovation, and climate, and also improving the human living conditions. What is sustainability? I know that many of you will think about sustainability. First thing what will come into your mind is the environment, right? But actually, sustainability is not only about the environment, it's also about how we can improve the human living condition. In another way, I would say it's about how we can meet the customer needs without having that negative impact on the environment. Okay, do you, oh, I'm sorry, I'm so sorry. I'm so sorry. I totally forgot what was the slide, sorry. So yeah, I will just repeat quickly again that this is where we are located in Hamburg, as I mentioned, and we are there in the market for 80 years. So yeah, my main focus is always about the sustainability. I know that sustainability is something really important that we know. It's not about the environment, as I mentioned. We need to understand how we can meet to be sustainable in terms of improving the human living condition, as I mentioned, and also how we can meet the customer needs without having that negative impact on the environment. So today I'm gonna speak about something really important. Are you aware that 100 billion tons of raw materials are what current linear economy uses every year? And but the rate of recapturing and recycling of these materials is nowhere near this. Our current economy is based on what we called it a linear model. If you see here, this model actually where raw materials are extracted from nature, processed into usable goods, and then sold in the market, then used by you and me before actually it got discarded. In another way, I would call this model as a take, make, waste model, which is unsustainable model, as you see here in the slide. What we need actually to do is to focus on another model. In the other hand, it's called a circular economy model, as you could see, where we focus more in aims to eliminate the waste by designing products and services to be reused, repaired, and recycled. That means products can be cycled round and round, if you could see, without creating any waste. This actually model, the circular economy model goal here is to reduce the need of the raw materials and saving the cost and minimizing the environment impact. Embracing this circular model, actually, which we are calling it the circular economy principle, can lead to innovative business models that are resource efficient and sustainable, offering long-term benefits for both nature and business. Okay, when it comes to recycling, I know that many of you are using this kind of plastic water bottles. And whenever you are seeing this symbol in the market, anywhere in any product, you will think that it can be easily recycled, right? Many of you will just use the water bottle and then you'll discard it, and then you will think it will magically be recycled. And this is actually what we call wish cycle, that you wish it can be cycled. But the reality, or the fact that only 9% of the plastic created has been recycled. Recycling is often seen as the best way to deal with the waste, but it has got limitations due to the complexity of the materials and the confusion around what can be recycled. In another hand, also, we need to think very well, because nowadays there are many companies spending more time actually and more money claiming that they have a green products through advertising and marketing, rather than actually implementing the business practices that minimize environmental impact. And this is actually what we are calling it greenwashing. So please avoid greenwashing. Okay, I believe that many of you also thinking a lot about why the climate nowadays change. So as you are all aware that fossil fuels are burned into to make energy, and but byproduct actually released back into the atmosphere is carbon. So that carbon used to be stored in all that organic materials. Carbon is usually absorbed and recycled by plants and marine microorganisms, but the rate of release has become faster than the rate of absorption. So all that additional carbon is creating a heat effect, which is actually making the planet like a giant greenhouse, and that is what is changing the weather nowadays as a result. From other side, also, there are other consequences happening, like increased the CO2 results in warming oceans, rising sea levels, strong storms, severe droughts, and larger wildfires. Addressing the climate change is a scientific challenge, I would say, that requires innovation and collective will to mitigate its effects. Something really good happening that nowadays there is a good focus. Sustainability regulation and reporting became something very important. The development of financial reporting has evolved over centuries, and now sustainability reporting is becoming a crucial part of business transparency. Most of large companies follow the Global Reporting Now initiative, which is called GRI, and the Task Force also on Climate-Related Financial Disclosures, TCFD, for sustainability reporting. New regulations also, like the EU Corporate Sustainability Reporting Directive, and which require actually many companies to disclose their environmental and social impacts, adding significant reporting responsibilities to that. So I believe when I'm talking always about sustainability, I met many customers worldwide. Whenever I'm telling them about sustainability, the first thing will come to their mind that it's very costly, right? It's costing a lot. It will be very expensive than our normal, say, products which we used to use. But the reality that the belief that sustainability always costs more is a myth. Sustainability should be viewed as an investment, similar to the marketing and R&D, rather than just a cost. Sustainability also can reduce the cost, lower the risk, and boost the revenues and enhance the brand value. Investing in sustainability can also lead to long-term benefits such as a customer loyalty, employee engagement, and overall business resilience, addressing major issues like the climate change, as I mentioned, and inequality is essential for a healthy economy and business success. So what we have done as Eppendorf as a company, We actually started since 2019 assembling most of Eppendorf products on 100% renewable power. So most of our products from 2019 until 2021, until today actually, but from 2019 until 2021, we reduced almost 60% of the carbon dioxide emissions. I know that you are aware that we are manufacturing several products, so how we are controlling all these kind of products. When it comes to liquid handling, for example, we are manufacturing the manual pipettes, the consumables like pipette tips, automated liquid handling, dispensers, and also combi tips, pipette controllers, and bottle top dispensers. And when it comes to cell handling, we are also producing manufacturing many products like fermentation and bioreactors, single-use reactors, CO2 incubators and shakers, and biological shakers. And when it comes to sample handling, we are manufacturing centrifuges and concentrators, high-speed and ultra-centrifuges, mixers, thermocyclers, ultra-low freezers, and other consumables like PCR plates and tubes and all. So how we are controlling all these products? If you could see that many of our products got the ACT label. It's very important to know about the ACT label. What is ACT label actually? It's environmental label, impact factor label, which is independent product validations. It's like the nutrition labels where you can get the product rates in sustainability related categories based on the R&D, the production, logistics, and also marketing and usage and disposal. So if you could see most of our products, we aimed that we changed the production in a way that we got it ACT label. And also we are aiming that by 2028, most of our products will be having the ACT label soon to ensure to our customer that we are presenting a sustainable product in the market. So yeah, what else? We are aiming also by 2028 to be neutral. So we will be by 2028 zero emissions of carbon dioxide as a company, and we invested heavily in that. So again, many people will tell me it's again about plastics everywhere. I think all of you are using many plastics on a daily basis, tips, tubes, plates, everything around you in the lab is containing plastics. So how can we reduce that? So actually the biggest challenge which we faced as Eppendorf for us was how we can meet the customer needs without affecting our planet. So we invested heavily in coming up with a new product. This product is called bio-based. Bio-based, actually, it's a new consumables product. It's mainly manufactured from the used cooking food oil in Germany, so that we are coming up with a sustainable product. And we also, not only that, we designed a very nice tool to help our customer knows how they can reduce the carbon emissions. If you go to our website, for example, you can use this tool. It's very useful. You can easily mention how many tips, for example, you are in a daily using it. For example, 288 tips you are using. And once it is calculated, it will show you per day how much you are reducing the carbon, and per year how much you are saving in terms of the carbon emission. And in reality, if you are looking at the two products, the one which is fossil fuel based and the one which is made of the used cooking food oil, you will never differentiate between the two products at all in terms of quality, in terms of the material. Unless I'm putting label in that, I will also not be able to differentiate which one is the bio-based, the sustainable consumable, and which one is the normal based fossil fuel. And in terms of price-wise, it's the same. With that, actually, I believe about this statement a lot, that companies that solely focus on competition will ultimately die, but those that focus on value creation will thrive. And this is why Eppendorf in the market now for 80 years. Thank you very much.
Thank you so much, Mrs. Abdul, for this interesting presentation in which you highlight the importance of incorporating sustainability in our daily life in order to preserve the ecosystem and also to preserve the life. So now we will move to our next and last presentation that will be made by Mrs. Chiao from MGI-Tech, China. So she will will give a presentation or lecture entitled From Simple to Data, Comprehensive Sequencing Solution for Biodiversity Genomics by MGI-Tech. So Mrs. Chiao is a senior field application scientist at this company, and she has over 6 years of experience in next generation sequencing for plants, animals, and microbes, and supports end-to-end genomics solution worldwide. So the floor is yours.
Good morning, ladies and gentlemen. My name is Zheng Yu, and I am the FAS from MGI-Tech. So today is a great honor for me and my colleague Hui Juan, who is our sales manager, to introduce BGI and what technical solutions we can provide for biodiversity genomics research. So I guess many of you haven't heard about BGI, so I need to spend some time to introduce who we are, how we work, and what solutions we can provide for you. So actually, BGI was founded in 1999 because of the Human Genome Project. So at that time, China undertook part of the work to sequence 30 million base pairs of chromosome 3 of human genome. So some of our founders and co-founders were the member of the project. So as a big group, we have over 6,000 employees, and we also have many departments and subsidiaries, and MGI-Tech is one of them. So MGI-Tech is aiming to be an outstanding service providers in life science research. So we have provided services in more than 100 countries and regions, collaborating with over 10,000 organizations and 30,000 collaborators. And as a service provider, we have comprehensive product lines. So for in NGS part, we have genomics, transcriptomics, single-cell omics, and spatial omics. And also in mass spectrometry part, we also have proteomics and metabolomics services. And in MGI-Tech, we provide end-to-end service from sample preparation to library construction to sequencing and also to the data interpretation. So we have excellent teams of experts who provide high quality services to our customers. And there's no doubt that the sequencers and equipment we use when we are providing technical services to our customers are really important. So one of the advantages that BGI is most of our sequencers and developments are developed by our own. For example, in short-read sequencing, we have DMB6 series. Mostly we use DMB6 T7 and DMB6 G400 to provide technical services. And for long-read sequencing, for sure we have PacBio Revio, which is really commonly used. And also we are developing our own technology called the Cyclone-seq. And in single cell omics, we also develop our own cell sorting platform called the DNB ELAB-C TIM4. And in mass spectrometry pods, we purchased many reliable machines. For example, the QE Astro from Thermo Fisher and TeamSTOF Pro from Bruker, and also the Q-Trap series from SciX. So to provide faster, localized, and more compliant services to our partners, we have established labs and offices all around the world. For example, Poland, Warsaw, and mainland China, and also Hong Kong, Japan, etc. And all of our projects are well recognized by our lab management and quality control system. So we have a broad range of certifications that make sure that we provide high quality data and services to our customers. Okay, so now you have more idea about who we are and how we work. So let's move on to the solutions we can provide for biodiversity genomics research. So here's a quick tour of our products. The first is the de novo sequencing. So we all know that high quality reference is the key to the downstream molecular research. So 10 years ago, we can only do like small or simple genomes, but thanks to the development of the sequencing technology and the algorithm, right now it is possible for us to get pan-genome, even T2T genome. So for a T2T genome, we have our solutions that we will need like 100x DNB-seq short reads plus 50x hi-fi plus 50x ultra-long and 100x high-C reads. And for single or pan-genome, we also have our own solutions. And compared to plants or animals, the genome of microbials are less complicated. So 100x DNB-seq reads and plus 100 hi-fi or cyclone-seq reads are enough to get a high quality genome of microorganisms. And scientists now, some of the scientists are actually focusing on molecular breeding, and especially for those economically valuable plants or animals. So based on whole genome technology, we can get a large amount of variations, including SNPs, indels, CNVs, SVs, and we can link these variations to the population evolution or agronomic traits using different algorithms such as selection sweep, GWAS, QTL mapping, etc. And actually, BGI earned its reputation by plenty of excellent works in plant and animal field at the first beginning. So both in our dry labs and wet labs, we have expert teams that with abundant project experience. And as of April 2025, we have around 34 cover articles on CNS and around 500 publications. And here I want to show you a serious research of chickpea led by BGI. So earlier to 2013, the draft genome of chickpea was published by BGI, which lays the foundation of the chickpea molecular research. And in 2016, 100 chickpeas were sequenced, and we find a lot of CNVs and SVs that link to the agronomically traits. And in 2019, 400 chickpeas were sequenced, and the origin and evolutionary pathway were identified, and the genes related to some important agronomic traits such as heat tolerance, disease resistance was discovered. And in 2021, the pan-genome of chickpea was constructed. And in 2024, the 8 wild species of chickpea were sequenced, and the genus-level super pan-genome was constructed. So BGI is not only a service provider, we are also doing scientific research. So this first-hand experience gives us the insider's grasp of what researchers actually need, so that we can provide high quality service and better solutions for our partners. And in metagenomics part, BGI also has extensive project experiences and achievements. So BGI put many efforts in microbial related and ecological environmental related research. So almost every year we publish papers of microbial related research on great journals. And we mainly have two products that are focusing on meta samples. One is the amplicon sequencing, which tells us the composition of the species in the sample, while metagenomics gives us more accurate information of the genes and the functions. And compared to DNA level analysis, the RNA profiling shows us the gene expression that is more tightly linked to the phenotypic output, making it commonly used technology in scientific research. So the product line of RNA-seq is very mature in BGI. And earlier to 2009, we started to offer RNA sequencing service in the market. And right now we have processed more than 1 million samples, and there are more than 2,200 articles published by the DMB-seq, and the IF reached 12,000. And there are mainly 4 products in our RNA product line. The transcriptome sequencing and the iso-seq. They are focusing on the presence, gene expression, and the structural variations of mRNA. While iso-seq use long-read sequencing technology, and it is possible for us to get the full-length transcripts as long as possible. And if the sample doesn't have a reference genome, we can also perform transcriptome de novo sequencing. And we also have non-encoding RNA-seq products that are focusing on the gene regulation. For non-encoding products, we focus on non-encoding RNA, and also we have small RNA products that focuses on small RNAs. And nowadays, actually, the research hotspot changed from bulk level to single cell level. And the gene expression of single cell level help us to identify the developmental trajectories, the disease resistance mechanisms, etc. So BGI has our own developed cell sorting platform called the DMB Lab C series, which can perform cell sorting conveniently and efficiently. And right now we have more than 140 articles used the DMB Lab C series. And actually, BGI was the first to launch the single-cell RNA-seq services in the market. So we have many project experiences and can provide comprehensive solutions from sample preparation to data analysis to our customers. And besides the single-cell level information, people are now interested in getting the original spatial information to better understand the relationship between cell morphology, gene expression, and the local environment. So BGI has also developed our own spatial transcriptomics technology called the StereoSeq. So the sample slice will be put on the StereoSeq chip, and RNAs will be permeabilized from the slice, and the probes on the slice will capture the RNA, and in the meantime, add the spatial barcode on the RNA molecules so we can get the spatial information of the RNAs. So the resolution of StereoSeq is around 500 nanometers, which is the highest in the market. And the chip size is also flexible. You can choose the chip size according to the size of your samples. And we also have developed comprehensive data analysis softwares that help our clients to interpret the transcriptomics, spatial transcriptomics data. And actually, to be honest, it's not that easy to standardize the workflow of spatial transcriptomics, especially for plants, because there are huge difference between different plant tissues. but BGI keeps working on that. And right now we have published more than 16 articles in the plant field, focusing on the development of maize ear, the senescence of Rhabdopsis leaves, and also the sex determination in cucumbers and so on. And by the way, if you have your own library preparation strategies and is only seeking for sequencing services, we can also provide the pre-made library sequencing products. So we mainly use the DMB-seq, T7 and G400 to provide pre-made library sequencing services. The output of DMB-seq T7 is around 4,000 to 5,000 million reads per cell, and the output of DMB-seq G400 is around 4 to 5 million reads per lane. And the advantage of DMB-seq is that the duplicate is really low, and there is barely no index hopping issues. And sometimes DNA level and RNA level information is not as direct as the proteins and metabolites. So we also can provide proteomics and metabolomics services, including protein identification, protein quantification, untargeted and targeted metabolomics services. And we always recommend you to combine multi-omics data to deeply interpret the mechanisms and the organisms. So we also have multi-omics services, for example, the metagenomics plus metabolomics, the transcriptomics plus proteomics. And the last product I want to share with you is our Dr. Tom multi-omics data mining system. So we designed this system to better help our clients to analyze, visualize, and interpret the data without any programming skill required. So right now we delivered our RNA-seq, WGBS protein metabolomics and metagenomics results on this system. So right now we have more than 20,000 users and more than 600 published papers citing the Dr. Tom system. And Dr. Tom integrates the information from public database, and through our table chart design and the abundant analysis tools, Dr. Tom can realize real multi-omics data mining. And besides standard delivery, we also support the clients to upload their own data to Dr. Tom so that you can analyze the data by Dr. Tom. And this is the website of our Dr. Tom system. And if you're interested, you're welcome to register an free account on this website and use our demo data to try this system. So that's what I want to show you today. So I hope after my introduction, you will get more details about BGI. And you are also welcome to reach out to us on our booth. And here's the contact information of our sales manager. And thank you again.
So thank you so much, Mrs. Hyang, for this great presentation and all this solution that has been developed by BGI. Honestly, I didn't know about the company. So due to your presentation, now I know that you are one of the leaders worldwide in terms of providing solution for genomics. So now we will move to the Q&A session. So I will ask the audience if there is some questions to our panel.
Hello. Hi. So I have a question for Dr. Laili. Right. So the presentation was about how MGI is bringing innovation for North Africa. Although we've seen in the presentation that there is a R&D unit in MGI, but we don't know if we have that in Morocco, and what is the percentage of North African, for example, in R&D. Also, you talked about some papers and some projects going on with MGI for innovation and research in genomics, but we do want to know, is there any projects going or achieved in North Africa again? And is there any papers published here? And so on. So I would like really to know your opinion, and if you could talk a little bit more about this.
Thank you for your question. About you ask about the installation in Morocco or North Africa? Both. I can answer about Morocco. We don't have the installation. We have the first installation in few months in Innovation City in University of Hassan II, G99 with the SP100 for application metagenomics and the microbiologic research. And for North Africa, I don't have the idea. We have with us channel partners Ayub Sabri. I think he can answer this question about Algeria and Tunisia.
Can give him the mic for the answer.
Thank you for your question. Yes, for North Africa, as Fatem Zara said, for Morocco, are maybe in few weeks that we installed the first one in Morocco. For the others region, for Algeria, we already have two instruments, G400 with the library preparation, the SP960, and also G99 for a diagnostic lab, not for research, but for the G400 is coupled in university hospital and for research for rare disease and also for biodiversity. So two parts that are working now for whole exome and the whole genome sequencing. For Tunisia, we are still also for the first installation, already have the first G99 instrument that will be installed next month. Inshallah. Thank you.
Okay. So I would like, first of all, to thank the presenters for the good presentation. And my question goes to Ms. Sheima, the Eppendorf team. In your presentation, you mentioned something about the goal of going to 0% carbon emission. So I'd like to know what's the plan and how are you planning to do this so that you can achieve this goal? Thank you.
Thank you for the question. So as I mentioned in my presentation about the ACT label, which is very important nowadays, it's like kind of a validation for all the products which being manufactured by any company. It will show you how much the consumption of the energy, the materials, the R&D, the marketing, the disposal, all these details about the product, you will get it in the ACT label. And this also will ensure to our customers that if really our product is sustainable or not. As I mentioned, many companies nowadays is doing greenwashing. They are not at all sustainable, but they are investing a lot in advertising about the green initiatives without taking any actions in terms of, producing a really sustainable product. I hope that helped. And also in another hand, just wanted to add that also, as I mentioned, we changed all our assembling all our products. It is done by renewable energy. It's which is ensuring you that 100% is renewable energy in terms of the production. Yeah. Thank you. I hope I answered your question. Thank you so much.
Any other question?
There's an online question that's directed to BGI. Dawit Abba asks, to BGI, how can we access the pre-made library sequencing service?
You can prepare your libraries and directly send the libraries to our Poland lab. And before this, you should contact our sales manager. Yes, thank you.
Any other? I do have one, if you allowed me. So it's a question to you again. So I was intrigued with the stereo-seq technology. So it was the first time that I heard about it, and I would like to have more information about it. Is it convenient to all the type of samples? Because as you explained in your presentation, it was the example was a brain section. So is it convenient for all? This is the first question. Convenient to all types of samples. And in terms of preparation, do we need a certain expertise in terms of preparing the slides before going further with the analysis?
Okay, thank you for your question. So the stereo-seq is a quite new technology, and we launched it last year or the year before last year. So the first question is if this technology is applied to all of the samples. So first, it is more easier to process with animal samples because the plant tissues are very different. And due to the huge difference, we will need to apply different methods when preparing sample, and it is not a standardized workflow. So every project of plants should be customized. Yep. And the second question is, when preparing the sample, what materials we especially need. So for stereo-seq, we have two solutions. One is for fresh frozen sample, and the other is for FFP samples. And for FFP samples, you will send us the FFP blocks or slices, and we will do the the section of the slice and do the subsequent workflows of the stereo-seq. But for for fresh frozen samples, we would need the customers to embed the samples in OCT and then send us the OCT box. Yeah, I hope this will help you. Thank you.
Thank you so much. Any other question?
I actually have a question myself. I was very interested in the Dr. Tom tool that you guys have developed, and I would love for you to expand upon how it was created, if that's possible, and as well as its usages. I found it to be very interesting.
Yes, thank you for your question. So we designed the Dr. Tom system in 2018. And we launched this system first in China and then to the global area. So this system is designed for those who is not majored in bioinformatics. So this system requires no programming skills. That means if you don't know how to code, you can also use this system to analyze your data and visualize your data. So the basic workflow is that we will deliver our analysis results. For example, for RNA-seq or for metagenomics, we will first deliver the result on the system. And we also equipped analysis tools on this system, but without any coding things. So you can directly click on the tools and select some samples and input some parameters you want, and the system will run the analysis for you. So this is how the system works. And right now, this system is free for register, and we have different types of demo data on the system, and you can register an account and try our demo data. Thank you.
And the data that you upload to the system is encrypted. It's confidential. Like the company doesn't have access to the data that you upload.
Sorry, I didn't hear it clearly.
No problem. So the data that you upload to the Dr. Tom system, it's encrypted. It's confidential. Like the government doesn't have access to.
Sure. It is only visible to you. Yep.
Any other question? So no other questions. So I would like to thank you all for your kindness, for all the information and data that you shared with us. It was very rich and instructive, and we hope to see you soon. Thank you so much. And with that, we close this second session of today.
Yeah.
Sorry. I have an announcement from the organizing committee. So it's related to this afternoon section. So we will start at 2 o'clock, please. Okay, have a nice day.
BGI Genomics is a leading global provider of a wide variety of omics services, covering genomic sequencing, mass spectrometry, synthetic biology, bioinformatics, and biodata management solutions. We are relentlessly committed to providing the highest quality and reliability of services. In particular, our unique Dr. Tom Multi-Omics interactive analysis platform has already supported countless researchers to publish papers in some of the world's leading journals. We remain dedicated to advancing genomic discovery and leveraging our world-leading experience to help our partners. We are committed to driving discovery even further. BGI Genomics. We sequence, you discover.
Un son, un, deux. Un son. Un son, un, deux, test. Un son. Un, deux, test, test. Un son, un, deux. Un son. Un son, un, deux. Un, deux, test. Un, deux, test.
can't believe it's been 10 years since Illumina Biotech West Africa opened its door for business here in Nigeria and in the large West African region. And for over a decade now, we've been at the forefront of driving genomics and life science across the region.
It's been 10 years of excellence. It's been 10 years of hard work. I remember when I joined the company, we started from a very humble space within high IT.
It feels just like yesterday. I joined Inkaba in 2018. Since then, there has been significant growth.
With Central Africa being the most recent region to have a representation for Inkaba Biotech, our creation and existence has benefited considerably from experience and mentorship of Inkaba Biotech West Africa Limited, Ibadan, Nigeria.
Reflecting on the last 10 years showcases hard work, diligence, tenacity, excellent leadership, and help from God. At Inkaba Biotech Limited, our core values are quality, customer focus, integrity, teamwork, and others.
From groundbreaking research to empowering our team and customers through training and development, we've built a culture of continuous growth while staying true to our mission to facilitate life science research in West and Central Africa.
My name is Elma, customer service representative from PacBio West Africa Limited, Ghana.
My name is Yusuf, the manager for PacBio Ghana.
Good morning, I am Mamadou Dabo from Mali.
I extend our warmest congratulations on the 10th anniversary of PacBio Nigeria branch.
Congratulations to our counterparts and our colleagues in PacBio Nigeria for their 10th anniversary.
Happy 10th anniversary year to all Inkaba Biotech staff in West Africa region.
Happy 10th years anniversary to all of my colleagues from Nigeria, Cameroon, Benin, Mali, and Senegal. We are the West Africa team.
Having provided sequencing services in Nigeria for about 4 years now, we've come to understand the needs of the research space, and as such, we see the need for improvement. And in the future, we're looking to take up a bit more responsibility in this space.
We've really achieved a lot. There's still a lot more to achieve. I strongly believe that IBOA, as a company, Inkaba Biotech West Africa, has really positioned itself to be a major driver that will facilitate the growth of the biotech industry across West Africa.
We are not only celebrating the past, but looking to an even brighter future ahead. We will continue to collaborate, innovate, and make meaningful contributions to Africa and the world at large. Here's to 10 incredible years and an exciting journey ahead. Happy anniversary, Inkaba Biotech West Africa.
Long live Inkaba.
This is to many more years of growth and positive impact to science across Africa. Happy 10th anniversary, Inkaba Biotech West Africa. Cheers.
As we look ahead, Inkaba Biotech remains committed to driving innovation and technological advancements in the life science and genomic space. We intend to do this by investing heavily in the latest equipment and sequencing technologies, empowering scientists across the continent so they can continue to do the amazing work they do. And very importantly, we also plan to serve new regions within the territory by expanding our tentacles into countries where we currently do not have a presence. So I hope you can join us in creating this amazing journey.
Despite the fact that resources are limited in Africa, the team has steadily developed the enterprise, including the setup of an own lab that provides summer sequencing services in Ibadan. And we look forward to add other genomic services like next generation sequencing using PacBio sequencers like we do here in Pretoria. As Inkaba Biotech, we aim to contribute within our means to the science and economic development on the African continent, a continent that has a vast diversity and needs so much more equality. We have created more than 40 jobs at our offices in Nigeria, Ghana, and Senegal, and this will continue as the need for application in life sciences and diagnostic develop in West Africa.
BGI Genomics is a leading global provider of a wide variety of omics services, covering genomic sequencing, mass spectrometry, synthetic biology, bioinformatics, and biodata management solutions. We are relentlessly committed to providing the highest quality and reliability of services. In particular, our unique Dr. Tom Multi-Omics interactive analysis platform has already supported countless researchers to publish papers in some of the world's leading journals. We remain dedicated to advancing genomic discovery and leveraging our world-leading experience to help our partners. We are committed to driving discovery even further. BGI Genomics. We sequence, you discover.
Well, I can't believe it's been 10 years since Illumina Biotech West Africa opened its door for business here in Nigeria and in the large West African region. And for over a decade now, we've been at the forefront of driving genomics and life science across the region.
It's been 10 years of excellence. It's been 10 years of hard work. I remember when I joined the company, we started from a very humble space within high IT.
It feels just like yesterday. I joined InCaba in 2018. Since then, there has been significant growth.
With Central Africa being the most recent region to have a representation for InCaba Biotech, our creation and existence has benefited considerably from experience and mentorship of InCaba Biotech West Africa Limited, Ibadan, Nigeria.
Reflecting on the last 10 years showcases hard work, diligence, tenacity, excellent leadership, and help from God. At InCaba Biotech Limited, our core values are quality, customer focus, integrity, teamwork, and order.
From groundbreaking research to empowering our team and customers through training and development, we've built a culture of continuous growth, while staying true to our mission to facilitate life science research in West and Central Africa.
My name is Emma. Customer service representative from PacBio West Africa Limited, Ghana branch.
My name is Yusuf, the manager for PacBio Ghana.
Good morning, I am Mamadou Dabo from Mali.
I extend our warmest congratulations for the 10th anniversary of PacBio Nigeria branch.
Congratulations to our counterparts and our colleagues in PacBio Nigeria for their 10th anniversary.
Happy 10th anniversary year to all Inkaba Biotech staff in West Africa region.
Happy 10th years anniversary to all of my colleagues from Nigeria, Cameroon, Benin, Mali, and Senegal. We are the West Africa team.
Having provided sequencing services in Nigeria for about 4 years now, we've come to understand the needs of the research space, and as such, we see the need for improvement. And in the future, we're looking to take up a bit more responsibility in this space.
We've really achieved a lot. There's still a lot more to achieve. I strongly believe that IBOA, as a company in biotech West Africa, has really positioned itself to be a major driver that will facilitate the growth of the biotech industry across West Africa.
We are not only celebrating the past, but looking to an even brighter future ahead. We will continue to collaborate, innovate, and make meaningful contributions to Africa and the world at large. Here's to 10 incredible years and an exciting journey ahead. Happy anniversary Inkaba Biotech West Africa.
Long live Inkaba.
This is to many more years of growth and positive impact to science across Africa. Happy 10th anniversary Inkaba Biotech West Africa. Cheers.
As we look ahead, Inkaba Biotech remains committed to driving innovation and technological advancements in the life science and genomic space. We intend to do this by investing heavily in the latest equipment and sequencing technologies, empowering scientists across the continent so they can continue to do the amazing work they do. And very importantly, we also plan to serve new regions within the territory by expanding our tentacles into countries where we currently do not have a presence. So I hope you can join us in creating this amazing journey.
Despite the fact that resources are limited in Africa, the team has steadily developed an enterprise, including the setup of a genome lab that provides summer sequencing services in Badan. And we look forward to add other genomic services like next generation sequencing using biosequencers like we do here in Pretoria. As Inkaba Biotech, we aim to contribute within our means to the science and economic development on the African continent, a continent that has a vast diversity and needs so much more equality. We have created more than 40 jobs at our offices in Nigeria, Ghana, and Senegal, and this will continue as the need for application in life sciences and diagnostic develop in West Africa.
BGI Genomics is a leading global provider of a wide variety of omics services, covering genomic sequencing, mass spectrometry, synthetic biology, bioinformatics, and biodata management solutions. We are relentlessly committed to providing the highest quality and reliability of services. In particular, our unique Dr. Tom Multi-Omics interactive analysis platform has already supported countless researchers to publish papers in some of the world's leading journals. We remain dedicated to advancing genomic discovery and leveraging our world-leading experience to help our partners. We are committed to driving discovery even further. BGI Genomics. We sequence, you discover.
can't believe it's been 10 years since Illumina Biotech West Africa opened its door for business here in Nigeria and in the large West African region. And for over a decade now, we've been at the forefront of driving genomics and life science across the region.
It's been 10 years of excellence. It's been 10 years of hard work. I remember when I joined the company, we started from a very humble space within high IT.
It feels just like yesterday. I joined INCABA in 2018. Since then, there has been significant growth.
With Central Africa being the most recent region to have a representation for INCABA Biotech, our creation and existence has benefited considerably from experience and mentorship of INCABA Biotech West Africa Limited, Ibadan, Nigeria.
Reflecting on the last 10 years showcases hard work, diligence, tenacity, excellent leadership, and help from God. At INCABA Biotech Limited, our core values are quality, customer focus, integrity, teamwork, and others.
From groundbreaking research to empowering our team and customers through training and development, we've built a culture of continuous growth while staying true to our mission to facilitate life science research in West and Central Africa.
My name is Emma, customer service representative from PacBio West Africa Limited, Ghana.
My name is Yusuf, the manager for PacBio Ghana.
Good morning, I am Dabo from Mali.
I extend our warmest congratulations on the 10th anniversary of PacBio Nigeria branch.
Congratulations to our counterparts and our colleagues in PacBio Nigeria for their 10th anniversary.
Happy 10th anniversary year to all INCABA Biotech staff in West Africa region.
Happy 10th years anniversary to all of my colleagues from Nigeria, Cameroon, Benin, Mali, and Senegal. We are the West Africa team.
Having provided sequencing services in Nigeria for about 4 years now, we've come to understand the needs of the research space, and as such, we see the need for improvement. And in the future, we're looking to take up a bit more responsibility in this space.
We've really achieved a lot. There's still a lot more to achieve. I strongly believe that IBOA, as a company, INCABA Biotech West Africa, has really positioned itself to be a major driver that will facilitate the growth of the biotech industry across West Africa.
We are not only celebrating the past, but looking to an even brighter future ahead. We will continue to collaborate, innovate, and make meaningful contributions to Africa and the world at large. Here's to 10 incredible years and an exciting journey ahead. Happy anniversary, INCABA Biotech West Africa.
Long live INCABA.
This is to many more years of growth and positive impact to science across Africa. Happy 10th anniversary, INCABA Biotech West Africa. Cheers.
As we look ahead, INCABA Biotech remains committed to driving innovation and technological advancements in the life science and genomic space. We intend to do this by investing heavily in the latest equipment and sequencing
BGI Genomics is a leading global provider of a wide variety of omics services, covering genomic sequencing, mass spectrometry, synthetic biology, bioinformatics, and biodata management solutions. We are relentlessly committed to providing the highest quality and reliability of services. In particular, our unique Dr. Tom Multi-Omics interactive analysis platform has already supported countless researchers to publish papers in some of the world's leading journals. We remain dedicated to advancing genomic discovery and leveraging our world-leading experience to help our partners. We are committed to driving discovery even further. BGI Genomics. We sequence, you discover.
Well, I can't believe it's been 10 years since Illumina Biotech West Africa opened its door for business here in Nigeria and in the large West African region. And for over a decade now, we've been at the forefront of driving genomics and life science across the region.
It's been 10 years of excellence. It's been 10 years of hard work. I remember when I joined the company, we started from a very humble space within IITA.
It feels just like yesterday. I joined InCaba in 2018. Since then, there has been significant growth.
With Central Africa being the most recent region to have a representation for InCaba BioTech, our creation and existence has benefited considerably from experience and mentorship of InCaba BioTech West Africa Limited, Ibadan, Nigeria.
Reflecting on the last 10 years showcases hard work, diligence, tenacity, excellent leadership, and help from God. At InCaba BioTech Limited, our core values are quality, customer focus, integrity, teamwork, and others.
From groundbreaking research to empowering our team and customers through training and development, we've built a culture of continuous growth, while staying true to our mission to facilitate life science research in West and Central Africa.
My name is Emma, customer service representative from PacBio West African Limited, Ghana.
My name is Yusuf, the manager for PacBio Ghana.
Good morning, I am Mamadou Dabo from Mali.
I extend our warmest congratulations to the 10th anniversary of PacBio Nigeria branch.
Congratulations to our counterparts and our colleagues in PacBio Nigeria for their 10th anniversary.
Happy 10th anniversary year to all Inkaba Biotech staff in West Africa region.
Happy 10th years anniversary to all of my colleagues from Nigeria, Cameroon, Benin, Mali, and Senegal. We are the West Africa team.
Having provided sequencing services in Nigeria for about 4 years now, we've come to understand the needs of the research space, and as such, we see the need for improvement. And in the future, we're looking to take up a bit more responsibility in this space.
We've really achieved a lot. There's still a lot more to achieve. I strongly believe that IBOA, as a company in Biotech West Africa, has really positioned itself to be a major driver that will facilitate the growth of the biotech industry across West Africa.
We are not only celebrating the past, but looking to an even brighter future ahead. We will continue to collaborate, innovate, and make meaningful contributions to Africa and the world at large. Here's to 10 incredible years and an exciting journey ahead. Happy anniversary Inkaba Biotech West Africa.
Long live Inkaba.
This is to many more years of growth and positive impact to science across.
BGI Genomics is a leading global provider of a wide variety of omics services, covering genomic sequencing, mass spectrometry, synthetic biology, bioinformatics, and biodata management solutions. We are relentlessly committed to providing the highest quality and reliability of services. In particular, our unique Dr. Tom Multi-Omics interactive analysis platform has already supported countless researchers to publish papers in some of the world's leading journals. We remain dedicated to advancing genomic discovery and leveraging our world-leading experience to help our partners. We are committed to driving discovery even further. BGI Genomics. We sequence, you discover.
Well, I can't believe it's been 10 years since Illumina Biotech West Africa opened its door for business here in Nigeria and in the large West African region. And for over a decade now, we've been at the forefront of driving genomics and life science across the region.
It's been 10 years of excellence. It's been 10 years of hard work. I remember when I joined the company, we started from a very humble space within high IT.
It feels just like yesterday. I joined INCABA in 2018. Since then, there has been significant growth.
With Central Africa being the most recent region to have a representation for INCABA Biotech, our creation and existence has benefited considerably from experience and mentorship of INCABA Biotech West Africa Limited, Ibadan, Nigeria.
Reflecting on the last 10 years showcases hard work, diligence, tenacity, excellent leadership, and help from God. At INCABA Biotech Limited, our core values are quality, customer focus, integrity, teamwork, and others.
From groundbreaking research to empowering our team and customers through training and development, we've built a culture of continuous growth while staying true to our mission to facilitate life science research in West and Central Africa.
My name is Emma, customer service representative from PacBio West Africa Limited, Ghana.
My name is the manager for PacBio Ghana.
Good morning, I am Omodu Dabo from Mali.
I extend our warmest congratulations for the 10th anniversary of PacBio Nigeria branch.
Congratulations to our counterparts and our colleagues in PacBio Nigeria for their 10th anniversary.
Happy 10th anniversary year to all INCABA Biotech staff in West Africa region.
Happy 10th years anniversary to all of my colleagues from Nigeria, Cameroon, Benin, Mali, and Senegal. We are the West Africa team.
Having provided sequencing services in Nigeria for about 4 years now, we've come to understand the needs of the research space, and as such, we see the need for improvement. And in the future, we're looking to take up a bit more responsibility in this space.
We've really achieved a lot. There's still a lot more to achieve. I strongly believe that IBOA, as a company, INCABA Biotech West Africa, has really positioned itself to be a major driver that will facilitate the growth of the biotech industry across West Africa.
We are not only celebrating the past, but looking to an even brighter future ahead. We will continue to collaborate, innovate, and make meaningful contributions to Africa and the world at large. Here's to 10 incredible years and an exciting journey ahead. Happy anniversary, INCABA Biotech West Africa.
Long live INCABA.
This is to many more years of growth and positive impact to science across Africa. Happy 10th anniversary, INCABA Biotech West Africa. Cheers.
As we look ahead, INCABA Biotech remains committed to driving innovation and technological advancements in the life science and genomic space. We intend to do this by investing heavily in the latest equipment and sequencing technologies, empowering scientists across the continent so they can continue to do the amazing work they do. And very importantly, we also plan to serve new regions within the territory by expanding our tentacles into countries where we currently do not have a presence. So I hope you can join us in creating this amazing journey.
Despite the fact that resources are limited in Africa, the team has steadily developed an enterprise, including the setup of an home lab that provides summary sequencing services in Ibadan. And we look forward to add other genomic services like next generation sequencing using biosequences like we do here in Pretoria. As INCABA Biotech, we aim to contribute within our means to the science and economic development on the African continent, a continent that has a vast diversity and needs so much more equality. We have created more than 40 jobs at our offices in Nigeria, Ghana, and Senegal, and this will continue as the need for application in life sciences and diagnostic develop in West Africa.
please take your seats. I think we shall start before other guests come because we want to keep up to the schedule. So let me just check the program. Yes. So good afternoon, everyone, and welcome back to this afternoon session for today's program. This session is about oral presentations from AfricaBP young scientists. We have PhD students, postdocs, and also master's students. I just want to let you know that this session should be of 8 minutes maximum. So when I'm going to call the presenters, I invite them to respect their time. We will also have 2 minutes to take questions. And then hopefully the organizing committee will be here by then. Not the organizing, sorry, the scientific committee. So we will start with Dr. Farida Fatoumata. Dr. Farida Fatoumata is a postdoc student at Mohammed VI Polytechnic University. So her presentation will be genome-wide association mapping revolved candidate regulators of seed nutritional quality traits in Kabuli chickpea under Mediterranean environments. So Dr. Farida, are you here? Yes. So welcome. So you have 8 minutes. So yeah, please respect your time.
Okay, do you have my presentation?
Yeah, your presentation is there. I'm just going to give you the.
Okay. 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 Good morning, distinct participants. My name is Traore Fatmata Faida. I'm from Burkina Faso. I am pleased to present our research entitled Genome-wide association mapping reveal candidate regulator of seed nutritional quality traits under Mediterranean environment. Climate change is affecting agriculture worldwide with rising temperature, irregular rainfall, and more frequent droughts. These changes reduce water availability, soil fertility, and leading to lower crop yield, higher food price. At the same time, many people suffer from hunger, and many children face to protein and micronutrient deficiency, which affect their growth and development. Feeding this growing population in both quantity and quality is become a major global challenge. In this context, legumes represent a key solution for climate-smart and nutritious agriculture. Feeding this growing population in both quantity and quality is becoming a major global challenge. Chickpea is a major legume crop. It is rich in protein, micronutrients, and fiber, and it also plays an important role in food security and food sovereignty. However, its productivity is affected by climate change, especially in Mediterranean environment. In this context, the development of high-yielding, stress-tolerant, and nutritional chickpea germplasm is essential. Our study aimed to assess the population genotyping variability and investigate genotype by environment interaction for seed nutritional threat in order to identify superior germplasm with good nutritional quality. Also, to conduct GWAS analysis to identify candidate gene and SNP associated with seed nutritional quality. Sorry. Okay. A subset of 168 improved line or capillary chickpea select from a large magic population was subject to this study. These lines were cultivated under two Mediterranean conditions in Marchouch, Morocco, and Tarbes in Lebanon. To assess the protein content, we use the near-infrared spectrometry, and for concentration of nutrient in chickpea flour, we determine using a de-acid method followed by quantification by ICPOs. This plan explains how the experiment was conducted, from genotyping to data analysis. We genotype our chickpea sample using GBS method and kept about 766K SNP marker. Then we analyze genotype diversity, population structure, and linkage disequilibrium using this marker. A genome-wide association studies were performed using three statistical models, GLM, MLM, and FAB-CPU, use K and K plus PCA as covariance. A significant threshold with the study trace was selected using a significant threshold. For identification of candidate gene, we use the database of Caesar info and UnitProt. Now let's move to the results section. Because of time, I will only present the data of the main nutritional quality: protein content, iron content, and zinc content. In our study, we observed significant variation in protein and micronutrient concentration among the chickpea genotype. For protein, a significant decrease of about 21 were observed at Tarbes compared to Marchouch. For iron and zinc, the concentration were high, above 70 ppm at Marchouch and Tarbes. Okay, this dendrogram shows the nutritional profile in Marchouch and Tarbes of the study genotype. We identify genotype with high level of protein, iron, and zinc at both seeds. In red, we identify 6 genotypes with high iron and zinc content. In light green, we also identify 4 genotypes with high protein. 4 genotypes with high protein and high iron content. We also identify 4 genotypes with high protein and zinc content at both seeds. This genotype will be an important resource for breeding program focused on improving the nutritional quality of chickpea seeds. Before performing the GWAS analysis, it is important to study the population structure and linkage disequilibrium to improve the mapping resolution and reduce false positive. In our study, we analyzed the population structure using 766K SNP. In our study, we used the Lie package in A to estimate the number of ancestral groups, testing the K value for 1 to 15. The optimal K value was identified at 13, indicates the presence of 13 subpopulations. For linkage disequilibrium, a large LD block was observed on chromosome 4 with very low value, indicate the significant correlation between genetic markers. The genome-wide association study GWAS were performed using the AMVP package in A. We test 3 statistical models. From the center to outside, we have We have a model GLM, MLM, and FAM CPU. Among these models, the MLM model with Chi plus PCA as covariant was selected as the best fitting model. Here we present the result of this model with a Manhattan plot. For protein at Mashush, we detect 264 significant MTN on chromosome 1 and 5. At table, only one MTAs was detected for this element. For zinc, for iron, at Mashush, we detect 258 marker trait association distributed on chromosome 2, 3, 6, and 7, and 0 at table. For zinc, we detect 221 marker trait association on chromosome 6 and 0 MTA on a table. The annotation of these marker reveal genes involved in nutrient uptake, transport, and metabolism, which may play a key role in determining seed nutritional quality. To conclude, contrasting genotype with high level of protein, iron, and zinc in both sets were identified. We also identify a large number of marker trait associations. The identified promise genotype and molecular marker constitute valuable resources for future genetic study and the implementation of marker acid selection strategy to improve the nutritional quality of chickpea seed. Thank you for your attention.
Thank you, Dr. Farida, for your presentation. We have a couple of minutes to take questions either from the audience or Salah, please check if there are questions on the Zoom.
Does anyone have any questions from the hall? There doesn't seem to be any questions from the Zoom either.
Okay.
So therefore, we will move straight away to our second presentation. So our second presentation is from Ms. Hanan Al-Idrisi. Hanan Al-Idrisi is affiliated to the Biotechnology Unit, Regional Center of Agronomic Research of Rabat at INRA Rabat. So Hanan's subject will be a phase telomere to telomere reference genome assembly of the Moroccan argan tree, Argania spinosa. Hanan Idrisi. Sorry. The floor is yours. Please, you have 8 minutes. Yeah.
So, good afternoon, everyone. I am honored to be here at the African BioGenome Project as a presenter. My name is Hanan Idrisi, a PhD student at the Faculty of Science in Rabat, in National Institute for Agricultural Research. I am delighted to present for you a project today that has a significant achievement in plant genomics and conservation of the Argania tree. As you all know, the Argania tree is a special plant in our culture and has several uses. Yet, despite its importance, high-quality genomic resources have long been missing. This presentation will take you through the development of the first phase near telomere to telomere genome assembly for the species. And before starting, I would like to thank the committee organization, our national and international collaborators for supporting this work. So, The argan tree, known locally as argan and scientifically as Hydroxylum spinosum or Argania spinosa, is the only representative species for the Saputaceae family in North Africa, and it plays an important role, ecological and also socio-economic. This entire region, So this entire green region that you are seeing here is the biosphere of Argania, Ionisco-destinated area, and actually it's native to the west central of Morocco instead of south of Morocco as largely reported. As I already mentioned, beside its biological importance, Argania tree has also ecological, economic, and cultural values. Ecologically, the argan tree plays a crucial role in combating desertification and soil erosion. And economically, it provides argan oil, a very, of course, valued product, as well as food and wood resources for local communities. Unfortunately, the population of Argania spinosa has been in decline since the 19th century due to many reasons. For example, climate change, overgrazing, overexploitation, and also limited natural regeneration. In response, Morocco has launched the Generation Green 2020-2030 initiative, and it's aiming to balance environmental conservation with sustainable economic development. The main challenges for the development of agriculture of Argania spinosa in Morocco are many. So we find genetic variability. Argania is an outcrossing species. So as a result, we find a very high genetic heterogeneity. This makes it impossible to maintain early traits. We also find other reasons like the long juvenile phase and low natural regeneration. INRA has already registered 8 elite varieties, but there is still an urgent need for forest regeneration for Argania spinosa, but those challenges that I have already mentioned makes this objective a little bit complicated. So in the light of the alarming decline of Argania spinosa population, our objective was simple but also ambitious, developing a high-quality reference genome for Argania. This would be the first step to resolve many scientific challenges and will give us many valuable insights into its genetics, its biology, genetic diversity, and also mechanism of adaptation. So for the bioinformatic workflow, this pipeline presents our full journey to understand the genome of Argania spinosa. We used an hybrid approach that combined 3 types of sequencing data. First, the PacBio Hi-Fi long reads that gave long and accurate DNA fragments for base assembly. Second, the Hi-C data, which provide us with 3D chromosomal interaction, which help us to contact contacts into full chromosomes, and also RNA-seq data, which help us identify and annotate genes, of course, in combination with other approaches and tools. So in this slide, you can see the generated data from the sequencing technologies. We obtain a coverage depth of 130 for PacBio Hi-Fi, 152 for Hi-C, 200 for Illumina, and 61 for RNA-seq. And this indicating an excellent depth and an excellent depth for assembling a complex plant genome. For the genome size estimation, it gave us about 805 megabase pair by the flow cytometry here, and about 645 megabase pair in silico. The chimeras plot shows 2 peaks that you are seeing here. The first one is corresponding to the heterogeneity repetitive sequences, confirming the diploid and heterozygous nature of the genome. And around 69% of the chimeras are unique, indicating a genome largely composed of unique sequences, with about 31 being repetitive. And this is a commonly thing that we observe in plants. And this plant this slide summarizes the results that we obtained from the assembly of hyphaeism, and after that they were improved by the high-C scaffolding. The phased assembly produced two haplotypes, and the high-C scaffolding, and after the high-C correction and scaffolding, we achieved a highly contiguous genome composed only of 17 scaffolds covering around 620. The assembly shows excellent contiguity with an N15 that exceeds 50 millions. And this is accurately representing the genome structure and its heterogeneity. So in this slide, you can see the high-C contact map. This map presents and provides a visual representation of the spatial organization of Argania spinosa genome. Each point presents an interaction frequency between the chromosome loci, and the intensity of the color indicates the frequency of contact with darker shades. The clear diagonal line presents an intrachromosomal contacts, and the red blocks along it, each block corresponds to a chromosome, and confirming the correct assembly and structural organization of the genome. And next we have looked for the frequency of repetitive sequences in the genome of Argania spinosa, and we found that most of chromosomes have repetitive sequences except of these two chromosomes, and the C-cross besides represent the centenary regarding the closest genome species, which is the Shia tree, and we found a high centenary between these two species. So for this slide, it's the phylogenomic analysis to explore the evolutionary position of Argania spinosa. We used Viscophilo with 715 Visco genes, and the phylogenomic tree shows that Argania spinosa cluster closely with Vitellaria paradoxa, which is the Shia tree, and both belong to the hierarchical order. And this visual representation confirms their close evolutionary history and provides a context for understanding the genomic similarities we observed before. So to conclude, we can say that we have successfully built a high-quality reference genome that will provide us with a reference point for studying the genetic diversity for the species, and also the genetic variation across this population are essential for the conservation of Argania spinosa, and it will facilitate us to have more studies like transcriptomics, proteomics, and other studies. And beyond the scientific value, this genome can help us tackle practical challenges that I have already mentioned in the challenges, and such as improving genetic diversity, shortening the juvenile phase, and maintaining early traits that are so important for us. Thank you for your attention.
Thank you, Ms. Hanan, for your presentation and also for respecting the time. We can take 2 to 3 questions, either from our audience in here or through Zoom. Okay, Professor Sarah.
Thank you so much, Hanan, for this great, interesting presentation highlighting the importance of Argania spinosa as one of the as an endemic plant of Morocco. So I have just a question regarding the conclusion. So how can you mentioned in the conclusion that having this high quality genome drafts or genome sequence will advance research in Argania species. Mostly, it can also help in shortening the juvenile period. How?
It's actually about shortening the juvenile period, not typically like that, but improving studies like in vitro, then improving and selecting varieties that has elite traits. So not typically shortening the juvenile phase, but it's simpling it, not making it too complicated. What do you mean now? I don't know, we will know that later.
I actually have a question myself. So the work on Argania spinosa is very, very important.
Yes.
What other plant species in particular do you think research should focus on or move towards in the near future?
Other plants
Yes,
that we can
other
focus
plants,
on.
yes, that are important endemically to Morocco.
For me, there is so many plants that are endemic to Morocco, but my focus is on Argania spinosa. But I'm not going to say it's the only species that need our focus, but one of them. So I don't really have an example, but there is so many plants that are really need to focus on and to reserve them and conserve them.
Thank you,
There is a
Hanan.
question. There is a
There is?
question. Yeah, there's one.
Yeah, there's a question online.
Yeah, there is someone asking which chromosome was taken for sequencing?
Which chromosome?
Was taken for sequencing.
It's not which chromosome. We did a whole genome sequencing. Then the assembly gave us the whole chromosomes, not one chromosome.
Yeah, and also in addition to the question, I wanted to ask if the whole genome was done, sequencing was done in Morocco, or was everything done in Morocco?
No, it wasn't done in Morocco, but it was in collaboration with Morocco. The sequencing was done outside of Morocco, but in Morocco, it was in Morocco. I'm sorry.
So the long read and the short read and the high-seq and the RNA-seq, all
Yes.
4 of them were done in Morocco.
Yes, we have these technologies.
So everything was done in Morocco.
Yes.
This is a good work. Boabid. So, sorry, my name is Tango Ebenezer. I think one of the things we encourage is for the research to be done locally where the samples are gotten nationally. And if this was done, is this paper published yet?
It's under revision.
It's under revision.
Yes.
So everything was done in Morocco, Boabid?
Yes, it's done at INRA. At INRA, they have the machines, yes.
This is a fantastic example that I think that has been set, and I'm quite pleased with the presentation. So are we looking for, is there a preprint or something?
Sorry?
Is there a preprint?
Yes, it's in the late stage of review. It may be getting out in the next month.
Okay, I'll be looking forward to reading it because as this was done in Morocco, this is a clear example of what the continent of Africa and the countries needs to be doing. And I think we need to actually flag this kind of work and to show many countries that, this can be done 100% on the ground within the countries. Thank you so much.
Thank you.
Thank you, Hanan, for the presentation. We will move to our next oral presentation. So this is Ms. Saida Etizi. Saida Etizi is a PhD student both in the Faculty of Sciences in Rabat at University Mohammed V and also at INRA Rabat. So Saida Etizi will be speaking about the genetic diversity of local chickens in the Mediterranean area, Morocco, Algeria, and Tunisia. Saida, you have 8 minutes. Please respect your time, and the floor is yours.
Good afternoon, everyone. Thank you for this opportunity. It's an honor to be here with you. Today, I'm going to share with you a part of our work titled Genetic Diversity of Local Chickens in the Mediterranean Area, Morocco, Algeria, and Tunisia. Sorry.
Yeah, I think we can pick up noise from the background, yeah.
So before I start my presentation, I would like just to mention that this work is a part of ScalaMedi project, which aims to optimize the sustainable use and conservation of local genetic resources from the Mediterranean area, focusing on adaptation to climate conditions and consumer preferences. So as you all know, African continents faces different or similar challenges including food insecurity and climate changes, which causes a different or increase challenges in loss biodiversity and mortality of several local populations. Today, I'm gonna talk about specifically local chickens in the North African region, which was domesticated before several years, and we have several local breeds in different countries, Morocco, Algeria, and Tunisia, that are adapted to different conditions in the three countries. Also, we should take or give the importance of the poultry sector in the three countries, considering the importance of meat, of the poultry meat in the consumption in the three countries. So as you can see in this figure, the Africa is considered with the low production and consumption of the poultry meat in the world, as you can see here. But considering all different meat production and consumption in the Africa, chickens still the most meat consumption in this region. Sorry, okay. So here I'm just showing some figures considering the importance of this meat poultry production in the three countries, in Morocco, Tunisia, and Algeria. As you can see, the importance of this meat poultry in the consumption of our populations in the three countries. And we also mention here the importance of the production of meat poultry in Morocco, Algeria, and Tunisia, considering Morocco as one of the most production of the meat poultry in the region. But considering this importance of the poultry sector, we cannot neglect the different challenges of the local populations, animal populations in the world in general. But in Africa, we have different factors that affect negatively the evolution and the conservation of local breeds in this continent. So for the poultry sector or the chicken local populations, they are faced with different challenges, including climate change, which increase disease rate and genetic erosion, and reduce also adaptability of these populations. Also, we have a lack of characterization and conservation of these populations in our country and in Algeria and Tunisia also, which affect the genetic diversity and also the cultural heritage in this population in our culture in the three countries. Also, we have industrialization, which is the displacement of other lions or strains of local chickens, which decrease negatively the resilience of our local genetic resources. So, considering all these challenges, the objectives of our studies and the Scala Media project in general is characterization of local chicken populations, also discover distinct genetic markers of adaptation of local chicken in the several environment area in Morocco, Algeria, and Tunisia, and develop a different strategy of conservation and valorization of these local resources in the three countries. So our work, we started with a data collection in the three countries. Sorry, as you can see here in the maps, we collected a different or a merge of blood samples and phenotypic data in the three countries. Genotyping was done in the three countries also using genotyping area image 001 version 2, and a pipeline of bioinformatic analysis was done to analyze the genetic diversity and population structure of the local chickens in the three countries. So for a part of our findings, I'm starting with the natural diversity. As you can see here, populations in the 3 countries shows a moderate genetic diversity considering the natural diversity. Expected the heterozygosity was a little more in Morocco, in Moroccan populations comparing to the other countries. Also, we have a significant or an important nucleotide diversity. For the population structure, we did an analysis of FST fixation index. So as you can see in the results, we have a moderate genetic differentiation between the 3 countries, Morocco, Tunisia, and Algerian populations. We also done analysis of principal component analysis. So as you can see in the results, all the samples in the 3 countries shows a little bit more moderate differentiation between the 3 countries. This group is a group of individuals that were collected in Algerian groups, but it was collected in a group with industrial chickens, which shows this differentiation between these individuals and the whole populations in the 3 countries. So as you can see here, this is a presentation of just the individuals collected in Algeria. We can see clearly that these samples shows a clear differentiation between them and the other local chickens collected in villages. Also, for the genetic admixture, we did an analysis of Bayesian and ancestry inference. I present here results for the 3 countries, Tunisia, Moroccan populations, and the Algerian samples. So we can see clearly here that we have a different or a moderate differentiation between local Moroccan groups with some specific groups shown in some localities. In Tunisia also there is some differentiation, but in Algeria, as I mentioned earlier, this group that is clearly different from the other local chickens was collected in an industrial or in an industrial chickens. We did also an analysis for phylogenetic migrations and events in the different countries. So we can see here that we have a little differentiation between Algerian groups and Moroccan and Tunisian groups, as we can see here, with some genetic drifts of some groups in Morocco, such as Wazan, Ibn Saleh, and Taunet. This group of Tlemcen and Alger were the groups that were collected in the industrial chickens, so that's why they shows this differentiation from the other Algerian groups. But from Morocco, we saw in the previous analysis that we have some differentiation in this group from Wazan and Ibn Saleh also. In the conclusion, genetic diversity in North African local chicken population is crucial for their long-term survival and adaptability. Also, preserving the genetic resources of local chicken breeds is crucial to maintaining biodiversity and ensuring the long-term sustainability of poultry farm in North African countries. So thank you for your attention, and I would like just to thank all our partners in the 3 countries and the ScalaMD Consortium also. Thank you for your attention.
Thank you, Saida, for your presentation. Any questions from the audience?
Hello, so I have one question. So you, in the presentation, we talked a lot about genotypes and stuff, but I just felt like you skipped the phenotypic way of things. So when you see a chicken, how do you notice that this one is Bildi, or this is Moroccan indigenous chicken, or this is just crossbreeding of whatever? So what is the phenotypic traits that are attributed to only Bildi chicken, in your opinion? And how did you take your sample? We had no idea in the presentation.
So actually, it's a very huge project. So there was different tasks and work done. I didn't present the part of phenotypic characterization and the importance of it. For the samples, before we did the sample collection, we done a different we use the literature to define the characteristics that are define the local build chicken in our culture. So we choose the localities that are far from all the industrial commercialization. So we really choose the localities in very far villages from all from cities, from the industrialization chickens, and also we choose the importance, or we give the importance of the local populations that are defined the local build chicken just from the phenotypic aspects. For example, the color of feeder, the color of eyes, the age, also the color of shank. We know in our culture, chickens that have the color of shank yellow and yellow, yes, it's not a belly chicken, but it's not really, if we can see in the scientific research, it's just a different gene expression. So yes, we give the importance of this phenotype aspects that are known in our culture to define this, is it ability or no, but also we collect different samples because the genotype and the analysis after that will give us the information, is it ability or not. Actually, in Morocco, we did a comparison in analysis of data with other lines that are known in Morocco, for example, Fayoumi, Sasso, and other lines. We did this merge of genetic data and we compared them. And actually, there was a significant differentiation in the genotypic data between them. But in the beginning, to select the localities that we just based on the phenotype. And the second point is to choose the localities that are very far from sale points or industrialization poultry sectors, just to eliminate all the factors that can give us this mix between the belly chicken and the others. I hope I did answer the question. Thank you.
There is one question online that requests you to clarify what type of RNA sequencing did you use?
No, we just focused on genotyping of DNA genomic. We didn't do this parts, but we have also parts of epigenetic analysis. We did some tests of Illumina and RRBS analysis to analyze the epigenetic and the effect of environment factors. But for RNA, no, we didn't include this part in the project.
Thank you, Ms. Saida, for your presentation. I would, now you can go. Welcome. I would like to invite Monsieur Mouad Farhat. Monsieur Mouad Farhat is a PhD student at the Department of Veterinary Pathology and Public Health at IAV Hassan II. Mouad Farhat will be talking about the antibiotic resistance and first comprehensive genomic characteristics of Salmonella gallinarium isolated from poultry in Morocco. Mouad, you have 8 minutes to go. You're welcome.
Good evening, everyone. Before I start, I would like to thank the scientific committee for the opportunity they gave us to present the latest research we're doing concerning one of the most intriguing pathogens in the poultry industry, which is Salmonella gallinarum, and its full genomic characteristics that enable us to reveal its secrets and the mechanisms of virulence, antibiotic resistance, and reversion to virulence in some cases. So, before I start, I would start with a prologue. So, first of all, we can say that, sorry. I would start with the prologue. We all know that SG is an avian pathogen specific to avian species, and their characteristics is that they multiply in macrophages, and secondly, like the emergence of antibiotic resistance strains has raised concerns since they may increase morbidity and mortality in flocks, in addition to the possibility to transfer some AMR genes to other bacteria by gene transfer through plasmids. Additionally, one of the main threats is the possibility of reversion to virulence in some cases, which is like a menace to both avian and human populations. So the objectives of this study, we have as main objective, we have like the management of fowl typhoid in poultry farms in Morocco, with some specific objectives such as the genomic characterization of pathogen populations, and the development of molecular and bioinformatic tools for effective epidemiological surveillance of this pathogen. Thus, we used whole genome sequencing in order to dive into the genomic characteristics of 23 Moroccan SG isolates, aiming to shed light on the key elements contributing to their virulence and resistance to antibiotics. So for the study plan, first things first, we started with bacterial isolation. We isolated the bacteria from internal organs of chickens showing typical signs such as perihepatitis, pericarditis, etc. And they come from different types of forming flocks, such as lean and broiler chicken, turkey, and also partridge. So first, for the phenotypic analysis, so we started with the antibiotic susceptibility for the main antibiotics used in the avian industry. And then also we studied the mortality rate and lesions observed after autopsy. And for the genotypic analysis, using whole genome sequencing, the basic steps, so DNA extraction, purification, and then dosing using a nanodrop, and then we did the sequencing using Illumina NovaSeq 6000. And after that, we used bioinformatic tools to study the genomes of these 23 strains. So our first tool is BRIG, which is a blast ring image generator. It's a comparison with the reference genome. Then we use Busco phylogenomics to construct the phylogenetic tree. CARD and ResFinder databases to study the antibiotic resistance genes, the FDB database for virulence genes, SPI Finder for Salmonella pathogenicity islands, and also Plasmid Finder to study the plasmids. So as results, so this table, it summarizes the strains we had, like with the region, type of flock, age, vaccinated or not, and DNA concentration we had after extraction. So for the phenotypic features, the clinical signs, they included mainly slight hematomegaly with the liver congestion, pale keel, and the catarrhal enteritis. And for the antibiotic susceptibility, as you can see, so mainly the main antibiotic to which our strains were resistant is flumecine, with 56% of our strain being resistant. And additionally, 39.1 had intermediate resistance to colicin, and 34% to tetracycline and doxycycline. And for the other antibiotics, they were sensitive to all the other antibiotics we used. And for the genotypic features, as you can see, so this image represents the genome compared to the reference genome of the strain. It's SG287. And it shows a high similarity between our genomes and the reference genomes, demonstrating that the quality of our sequences and that they are actually SG strains. As you can see, there are no big differences from the sequences. And for the phylogenetic tree constructed using viscophylogenomics, as you can see, interestingly, there were like 3 clusters. As you can see, the cluster A, it's worldwide strains between 2013 and 2022. And for the cluster B, it's strains that are related to the SG9R vaccine. And for the cluster C, representing the Moroccan strains isolated from 2020 and 2022. So for the antibiotic resistance genes using CARD database, we were able to detect 26 resistance genes, and using ResFinder, we were able to detect 3 mutated genes that we will talk about later, AAC6 in all our strains, AAC3 IIA in strains A2 and A6, and BLA-TEM1 alpha in strain A6. Also, this gene will be discussed later on. We don't have enough time to. So this figure, it represents the whole genes. As you can see, there was no big difference between strains except for strain A2 and A6. This is a table summarizing the roles of these genes. Not to take too long, I will break it down for you. So mainly the main genes, they were coding for efflux pumps, efflux systems such as ACRA, ACRB, EMRA, B, and R. They are all efflux pumps genes. And for the virulence genes, we were able to detect 107 virulence genes in our strains. And using SPI finder, we were able to detect intact and incomplete Salmonella pathogenicity island. In this table, I did an annotation of these Salmonella pathogenicity islands to look for virulence genes that are present in these pathogenicity islands, and 71 out of 107 genes were all present in these Salmonella pathogenicity islands, which demonstrates the importance of these islands in the virulence. So to break it down again, as you can see, so mainly these genes are secreted via type 3 secretion system, 1 for SPI1, 2 for SPI2. So these secretion systems, they act as injectosomes, so they inject the virulence genes inside the cell. And one of the main genes is MGTB and MGTC, because they are responsible for the intramacrophage survival. And for the mobile genetic elements, an interesting finding is that, first of all, we detected the INCF2 and col 4401 plasmid in 22 of our 23 strains. And what's interesting is that we were able to detect a plasmid that was never described in avian SG before. It's INC1 alpha. And after blasting this plasmid, we were able to find that it comes from E. coli. And it's known to harbor beta-lactamase genes in E. coli, mainly BLA-TEM and BLA-CMY. So as you can see in this figure, you can see that the plasmids that were detected in our strains, and also the plasmids detected in strains retrieved from NCBI. And you can see at the top 2 strains, A6 and A2, that were harboring this plasmid that was described for the first time in SG strains. So, as a conclusion, we can say that the analysis of the complete genomes of 23 Moroccan SG strains revealed the presence of several genetic elements playing roles in different resistance and virulence mechanisms. And by deciphering this complex interplay between these factors, we provide a basis for the development of targeted strategies to prevent and control fowl typhoid. And in the future, it is essential to pursue research efforts to stay at the forefront of developments in antimicrobial resistance and new infectious threats posed by SG in order to safeguard both animal and public health. I would like to thank the Institute, Agronomic and the Veterinary Institute, Hassan II, Mohammed VI Polytechnic University, National Institute of Hygiene. Especially, I would like to thank Professor Siham Flahi, Professor Khayis Liman, Professor Mohammed Mouahid, Dr. Najia Amor, and the whole avian pathology unit at IAV Hassan II. Thank you.
Thank you, Muad, for your presentation. So, any questions from the audience? Either here, Salah, could you please check Zoom?
Yeah, there is someone who asks, what bioinformatics tools were used for comparative genomics analysis of the SG strains?
It's BRIG. It's a blast ring. In fact, it's a tool that enables us to align the whole genome with the reference genome. The reference genome of SG is SG287, and we did the BRIG tool to align them to see if it's like actually SG or something else.
There's another question that goes, what is the control method you recommend to treat SG?
Perfect. That's a perfect question. In fact, the vaccination, we can say that, how do we say? It's like a walking stick. You have to like give it to the flock in order to help it walk. But then, if it can walk without the walking stick, it's perfect. So basically, we use the vaccination to prevent, to treat. But then let's just keep in mind that it's just a walking stick that should help the flock move on and move on by its own. Yes.
Thank you very much, Muad. Just for the example you give, to get stick to follow always the vaccine and to get sure that it will work. Do you have any idea how we can do better? I mean, as you know, the rate of mutation in the strains is high. So the vaccine that works today, maybe it will not work in 2 months if you get new strains. Have you in mind any way to go ahead of that?
For me, I think that the best way is to control better the hygiene of the flock and try to how can I say, avoid any contact or anything that can introduce pathogens in the flock. I think this is the best way, and also for the antibiotic use and stuff like that. It's something that can prevent, but it doesn't. It's not the solution, like the ultimate solution for the problem. So I think the main solution is the hygiene of the flock, how it's treated since it comes and until it leaves the.
Thank you.
You're so welcome.
Are we good, Salah? Thank you, Muad, for your presentation. So we have 2 more presentations to go. Our next one is Miss Lamrani Khawla. Khawla Lamrani is a PhD student at the African Sustainable Agriculture Research Unit at University Mohammed VI Polytechnic. She will be presenting a study titled Morphometric and Genetic Characterization of the Indigenous Hassania goat of Southern Morocco. Khawla, the floor is yours. You have 8 minutes.
So good afternoon, everyone. I will discuss in this presentation the morphometric and genetic characterization of the indigenous Hassania goat of Southern Morocco. So to introduce, the global goat population in Morocco saw a sharp increase from 1961, reaching a peak around the early 1970s. And after this peak, there was a notable decline before numbers stabilized and gradually increased again in recent decades. So the goats play a vital role in arid and semi-arid regions by ensuring food security, utilizing poor grazing lands, and supporting rural economies. Among the emblematic species of this region, we can just found the domestic Hassania goat, which play a crucial role both ecologically and socio-economically in the region. So the Hassania breed originating from the Moroccan Sahara, descends from the Mahorera breeds imported from the Canary Islands. And it's well adapted to the arid conditions of the region, and it's renowned for its hardiness and its ability to produce high quality milk, and even in harsh conditions. So for the Mahorera goat is an important breed in the Canary Islands, and it's very known for its Mahorero cheese. So our objectives in this study is the morphometric characterization of the Hassania goat breed, aiming to describe its phenotypic traits and also to identify the maternal linkage between the Hassania and the Mahorera goat breeds using mitochondrial DNA markers. So as the materials and the methods for the morphometric characterization, we have done the collection of detailed morphometric measurements for goats across the Al-Ayoun Saqiya Al-Hamra region and Dakhla wa Dahab region to document phenotypic diversity following the universal parameters in the figure. The analysis of morphometric data using bioinformatics tools such as are for multivariate statistics, clustering, and pattern recognition. So as for the genetic characterization, there is a blood sampling of 150 goats for mitochondrial DNA D-loop sequencing, and we've used the different bioinformatic tools such as RStudio, Galaxy, and BioEdit. So as a result of the analysis of body measurement of goat population in southern Morocco, we have here in the we have here in the first analysis of PCA significant heterogeneity in the distribution of animals, and we can see in the second figure the identification of at least 3 distinct groups of goats. So for the traits analyzed, we have the variables with greatest impact are close to the PC1 and PC2 axes, like LG, LC, and LE variables. And we have some variables such as DY and LT1, which are equidistant between the principal, the PCA1 and the PCA2, and they contribute equally to the differentiation of the population. So as for this analysis of correlation, we have some strong positive correlations, except for a few such as LG and EP. And for the heat map, it represents distinct 2 groups of variables. As for the genetic analysis of goats population in southern Morocco, we have done this FST analysis, and it shows that there is a strong genetic similarities between some populations in Morocco, and we are just focusing on the Mahorera goat breed and the Hassania goat breed in their relationship, in their maternal linkage and relationship. So for this analysis of PCA, we have that there is an evident gene flow of among Moroccan goat breeds, and a slight genetic exchange observed between the Hassania and Mahorera populations. As for the DPCA, we have clear genetic structure among the goat population, and a clear genetic proximity between the Hassania and the Mahorera breeds. So here we can see, as shown before, that Hassania goat show no clear gene flow with other Moroccan goat breeds, but it shows a strong genetic exchange with the Mahorera, and it can be from a suggestion, shared ancestry, or recent introgression between these populations. So as a conclusion, the Hassania goat of southern Morocco exhibits distinct morphometric and genetic characteristics reflecting its adaptation to arid conditions, and genetic analysis reveals the clear differentiation between other Moroccan breeds and a strong genetic affinity with the Mahorera breeds. And thank you for your attention.
Thank you, Khawla, for your presentation. Any comments from the audience? Feedback, questions? Salah, any questions from the Zoom?
I have one question, please.
Okay, go ahead, Prof. Narjis.
The first one is I don't know, it's not a question, but since I'm from the scientific committee, is R a bioinformatic tool?
These what?
Is R a bioinformatic tool?
It's a statistic tool, but we use it to do some statistics analysis. And I just joined it to bioinformatics tools because I have some studies in the lab and there is a bioinformatics side. So I just joined it to.
I mean, because it was written in one slide, only R, a bioinformatic tool. That's why it triggered me.
Yeah.
But it's a programming language. So you talked about Hassania breed in the south, but we didn't hear about the population. Do you have any idea? What is the population?
What is the population in South? So we have different breeds in South.
No, just Hassania, not just Hassania breed. Do you know how many, for example, did you work in one region or two regions?
I worked in the two regions, the two different regions, the Hassania, the العيون الثقيلة الحمراء region and دخلة والذهب region. And for your information, the Hassania goat is especially there, but we cannot find it clearly in these regions because of extinction. I think it's extinct for from there. So
the hypothesis is it's indigenous to Morocco. What is the hypothesis of your thesis?
So it's indigenous to Morocco, but as a result of their extension, we conduct this study to re-establish this breed in Morocco.
Okay, thank you.
Any other question or feedback? Salah, please.
Good evening. Good afternoon. I will take you back a little bit to the objective of your study.
Yes.
I missed the objective of your study because I was talking to Professor Badawi. So I missed, was the objective of your study is to compare the two breeds or to study things happening in goats in Morocco? So this is the part of my question.
As a part of the project, we have the two objectives in the presentation that are first, the morphometric characterization of the population in South, and also the comparison between the two breeds to just identify the relationship between the two breeds, and which can allow us to continue the project.
Okay. Was this at the genetics or level?
Yes.
I mean, genetically, or even at the production level or phenotypical level, production, fertility, prolificacy, season, or just morphometric measurements?
So we've worked on morphometric traits for the first step, and we've identified the genetic diversity of these goats in the project. So we don't focus on some traits like the production and all these other traits. We are more focusing on genetic diversity and reproduction biotechnologies.
And the last part of my question, not question, is just for your information. I don't know if you had chance to go through some morphometric measurements or morphometric characterization of some local goat populations. We are not, at least at the level of current breeds, local populations of Middle Atlas, mainly in the region of Khnifra and Moulay Bouazza, and in the northern part of Morocco around Chefchaouen and the region. There have been some investigations concerning morphometrics.
Yes.
And there was, I think, some aspect of genetic study that has been done to characterize some goats. And the dairy goat of the region of the high Dra Valley, southern of Ouarzazate, there is one of the hypotheses is that the breed maybe derives from this Hassani goat, breed in southern parts of Morocco, and there was a migration or a diffusion along the valley, the Dra Valley, to reach Zagora and Ouarzazate. And I don't know if it's, I think, the opportunity to investigate at the genetic level to see if there is some connections in between these breeds and their ancestors, which is Hassani and the Spanish goat. Thank you very much.
Thank you so
congratulations for the good job you're doing.
Thank you.
No further questions? We're good. I'll move to the next one. Okay. So next, this is our last but not least presentation for this session. Our next oral presenter is Mr. Mohamed Larish. Mr. Mohamed Larish is fifth year computational engineering student, right? At the Faculty of Sciences and Technologies of Moulay Ismail University in Rashidia, Morocco. So Mr. Mohamed will be presenting about the cloud-native tools for detecting insecticide resistance in African malaria mosquitoes, a two-phase GWAS approach. So Mohamed, you have 8 minutes. So the floor is yours.
So good afternoon, everyone. My name is Larj Mohamed, and I'm a computer engineering student at the Faculty of Science and Technology in Rashidia, Morocco. Today, I'm on to present the work I have done in collaboration with Malaria Jane as a part of the Google Summer of Code program. This project focuses on developing a cloud-native tool to detect insecticides resistant in African mosquitoes, malaria mosquito, using a two-phase approach. First, here's a quick overview of the talk. First, we will start with the background and the motivation, then move into the project overview, technical contribution, results, and finding, then the impact and the future work. So for the motivation and why this work is measured, malaria remains one of the most Africa deadly disease, and mosquito resistance to insecticides has become a major obstacle for the control effort. To manage the resistance effectively, we need a genetic surveillance tool that can reveal which mosquitoes genes are driving the resistance. But with this motivation, there is a major challenge. In African mosquitoes, population are extremely genetically diverse. When we run the genome-wide association study or the GWAS, this diversity creates a false positive signals that sometimes can appear stronger than the true biological ones. So my goal was to build a computational approach that can separate those false patterns from the real resistance signals. Here's a diagram of the project. So to solve that, I designed a two-phase pipeline that ran entirely in the cloud. In the first phase, we ran a sensitive and fast chi-square genome scan to identify every possible candidate to resistant locus. And in the second phase, we verified those candidates and the top hits from the first phase using a more advanced statistical models, especially the mixed effects and the Bayesian models, to test whether each signal holds up once we count for the population structure. For the technical contribution, first, we created a function to allow the phenotypes data from the malaria gene API and the cloud. Then I built a component called the resistance simulator, a tool that generates realistic mosquitoes data with controlled confounding effects, such as country level differences in other frequencies. This simulation allowed us to simultaneously test whether our models could distinguish true biological signals from artificial caused by the population structure. Here's the results of the simulator resistance. As we can see, the simulation results, each color represents the mosquitoes from different countries. The differences in their others frequencies mimic the real-world confounding effects, making the simulated data behave very similarly to the actual African population. This setup give us a controlled environment to benchmark our models and test the results. Also, with the simulation system ready, I built a modular GWAS models. First, the logistic regression GWAS as a baseline, then mixed effects GWAS to correct for the population structure, and then a Bayesian model which perform probabilistically using a prior knowledge. These models are orchestrated through two components: the GWAS scanner that use the chi-square, and then the GWAS verifier, creating an unified cloud-ready analysis workflow. Now for the results, when we ran those models, we found that an uncorrected chi-square scan produced a false positive peak of -log10 p of p-value equal to 6.6. While the true resistance genes, the VGSC only appears at 5.8. This means that the naive statistical methods were flagging noise as stronger than the real signals. Once we applied the mixed effects model, those false peaks disappeared and the real resistance signals emerged clearly, proving that the accounting for structure is critical. Here's a comparison of the model. The mixed, as we can see here, the mixed effects approach consistently identify the true association while filtering out the population level artifacts that the simple logistic models or the Bayesian approach could not handle. This confirmed that our two-phase pipeline provide both speed and statistical rigor, which is essential for a large-scale genomic surveillance. The next step was to make the results accessible. For that, I developed an interactive dashboard built with Bokeh, a library for building visualization in Python that lets the researchers explore the GWAS results in real time. You can visualize the Manhattan plots, zoom in to a specific region, and compare the results between different models in all producer cloud-friendly interface. Here you can see the dashboard first. You will see the results of the whole scan of the genome. Then you can select the region that you are interested in. After that, you will automatically go for the region tab when you can see the region of interest in the region of interest. and then you can select the SNP that you want to see, and by then you can see the results of the SNP that are based on our models. Scientifically, this project strengthens malaria vector surveillance by providing a reproducible cloud-native pipeline for resistant detection. Personally, I learned a lot from this computational the computational efficiency with the statistical prior. Also, like asking the right questions can give us is initial as also as equal as the given the right answers, and also debugging becomes less about fixing code and more about understanding the biology behind the data. For the future work, next I plan to extend this pipeline to a full genomic-wide analysis across all chromosomes, expanding the BioGene framework to a hierarchical model, and connect the final output directly to a visualization dashboard. Thank you so much for your attending.
Thank you, Mohammed, for your presentation. Let's take a few questions from the audience. Okay.
I have a question for you, Sir Mohammed. Maybe I missed something, but could you please explain to us the database that you use? Because when speaking about genome-wide association scan, you need a Y variable, dependent variable, and independent variable access. What is Y in the database? What is access? So just to flow with you.
So the data is accessible via the malaria gene API. The samples are collected here in Africa and then sent to analyze in the lab in England. From the lab, the data engineer and data scientists filter and they clean up the data, and it's ready to use by scientists over the world via the API of malaria gene.
What there is in the database? What is the information in the database?
So the data is the whole genome of the mosquitoes, also the SNPs and the haplotypes. You can find all those information via the API.
This is the explicative variable. So what is what you would like to explain with this? The resistance.
Yeah.
Is the resistance information included in the database?
No. That the project was for. So in the project we worked with phenotype data that was selected also here in Africa. The data is just labeled as dead or survived the mosquitoes.
Died or survived. So it's binary variable.
Yeah, binary data.
But from where you get this information, binary?
From the scientists that selected the mosquitoes.
So for the same database?
Yeah, they spread the insecticide on the mosquitoes and they get the results if the mosquito died or survived those insecticides.
But when you use the mixed model, it was the logistic model, you mean?
Yeah, mixed effects model, yeah.
Logistic model, because it's not quantitative variable. Yes.
Yeah. So first I used the logistic regression model as a baseline.
Okay. Okay, thank you very much.
Thank you.
Any other questions? No? Okay, thank you, Mohammed, for your presentation. Yeah. So this was the last presentation of the oral presentation session from the young scientists. The scientific committee will have to take a few moments to deliberate, which is why we are going to go on a short break of 15 to 20 minutes maximum. I invite the scientific committee members to go into the hallways and also check the poster presentations. We will reconvene after 20 minutes maximum, and it will be decided on which was the best oral presentation and which was the best poster presentation. So see you in 20.
BGI Genomics is a leading global provider of a wide variety of omics services, covering genomic sequencing, mass spectrometry, synthetic biology, bioinformatics, and biodata management solutions. We are relentlessly committed to providing the highest quality and reliability of services. In particular, our unique Dr. Tom Multi-Omics interactive analysis platform has already supported countless researchers to publish papers in some of the world's leading journals. We remain dedicated to advancing genomic discovery and leveraging our world-leading experience to help our partners. We are committed to driving discovery even further. BGI Genomics. We sequence, you discover.
Well, I can't believe it's been 10 years since AfricaBP BioTech West Africa opened its door for business here in Nigeria and in the large West African region. And for over a decade now, we've been at the forefront of driving genomics and life science across the region.
It's been 10 years of excellence. It's been 10 years of hard work. I remember when I joined the company, we started from a very humble space within IITA.
It feels just like yesterday. I joined InCaba in 2018. Since then, there has been significant growth.
With Central Africa being the most recent region to have a representation for InCaba BioTech, our creation and existence has benefited considerably from experience and mentorship of InCaba BioTech West Africa Limited, Ibadan, Nigeria.
Reflecting on the last 10 years showcases hard work, diligence, tenacity, excellent leadership, and help from God. At Inkaba Biotech Limited, our core values are quality, customer focus, integrity, teamwork, and others.
From groundbreaking research to empowering our team and customers through training and development, we've built a culture of continuous growth while staying true to our mission to facilitate life science research in West and Central Africa.
My name is Emma, Customer Service Representative from PacBio West Africa Limited, Ghana.
My name is Yusuf, the manager for PacBio Ghana.
Good morning, I am Mamadou Dabo from Mali.
I extend our warmest congratulations for the 10th anniversary of PacBio Nigeria branch.
Congratulations to our counterparts and our colleagues in PacBio Nigeria for their 10th anniversary.
Happy 10th anniversary year to all Inkaba Biotech staff in West Africa region.
Happy 10th years anniversary to all of my colleagues from Nigeria, Cameroon, Benin, Mali, and Senegal. We are the West Africa team.
Having provided sequencing services in Nigeria for about 4 years now, we've come to understand the needs of the research space, and as such, we see the need for improvement. And in the future, we're looking to take up a bit more responsibility in this space.
We've really achieved a lot. There's still a lot more to achieve. I strongly believe that IBOA, as a company in Biotech West Africa, has really positioned itself to be a major driver that will facilitate the growth of the biotech industry across West Africa.
We are not only celebrating the past, but looking to an even brighter future ahead. We will continue to collaborate, innovate, and make meaningful contributions to Africa and the world at large. Here's to 10 incredible years and an exciting journey ahead. Happy anniversary Inkaba Biotech West Africa.
Long live Inkaba.
This is to many more years of growth and positive impact to science across Africa. Happy 10th anniversary Inkaba Biotech West Africa. Cheers.
As we look ahead, Inkaba Biotech remains committed to driving
BGI Genomics is a leading global provider of a wide variety of omics services, covering genomic sequencing, mass spectrometry, synthetic biology, bioinformatics, and biodata management solutions. We are relentlessly committed to providing the highest quality and reliability of services. In particular, our unique Dr. Tom Multi-Omics interactive analysis platform has already supported countless researchers to publish papers in some of the world's leading journals. We remain dedicated to advancing genomic discovery and leveraging our world-leading experience to help our partners. We are committed to driving discovery even further. BGI Genomics. We sequence, you discover.
Well, I can't believe it's been 10 years since Illumina Biotech West Africa opened its door for business here in Nigeria and in the large West African region. And for over a decade now, we've been at the forefront of driving genomics and life science across the region.
It's been 10 years of excellence. It's been 10 years of hard work. I remember when I joined the company, we started from a very humble space within high IT.
It feels just like yesterday. I joined INCABA in 2018. Since then, there has been significant growth.
With Central Africa being the most recent region to have a representation for INCABA Biotech, our creation and existence has benefited considerably from experience and mentorship of INCABA Biotech West Africa Limited, Ibadan, Nigeria.
Reflecting on the last 10 years showcases hard work, diligence, tenacity, excellent leadership, and help from God. At INCABA Biotech Limited, our core values are quality, customer focus, integrity, teamwork, and others.
From groundbreaking research to empowering our team and customers through training and development, we've built a culture of continuous growth while staying true to our mission to facilitate life science research in West and Central Africa.
My name is Emma, customer service representative from PacBio West Africa Limited, Ghana.
My name is Yusuf, the manager for PacBio Ghana.
Good morning, I am Mamadou Dabo from Mali.
I extend our warmest congratulations to the 10th anniversary of PacBio Nigeria launch.
Congratulations to our counterparts and our colleagues in PacBio Biotech Nigeria for their 10th anniversary.
Happy 10th anniversary year to all INCABA Biotech staff in West Africa region.
Happy 10th years anniversary to all of my colleagues from Nigeria, Cameroon, Benin, Mali, and Senegal. We are the West Africa team.
Having provided sequencing services in Nigeria for about 4 years now, we've come to understand the needs of the research space, and as such, we see the need for improvement. And in the future, we're looking to take up a bit more responsibility in this space.
We've really achieved a lot. There's still a lot more to achieve. I strongly believe that IBOA, as a company in INCABA Biotech West Africa, has really positioned itself to be a major driver that will facilitate the growth of the biotech industry across West Africa.
We are not only celebrating the past, but looking to an even brighter future ahead. We will continue to collaborate, innovate, and make meaningful contributions to Africa and the world at large. Here's to 10 incredible years and an exciting journey ahead. Happy anniversary INCABA Biotech West Africa.
Long live INCABA.
This is to many more years of growth and positive impact to science across Africa. Happy 10th anniversary INCABA Biotech West Africa. Cheers.
As we look ahead, INCABA Biotech remains committed to driving innovation and technological advancements in the life science and genomic space. We intend to do this by investing heavily in the latest equipment and sequencing technologies, empowering scientists across the continent so they can continue to do the amazing work they do. And very importantly, we also plan to serve new regions within the territory by expanding our tentacles into countries where we currently do not have a presence. So I hope you can join us in creating this amazing journey.
Despite the fact that resources are limited in Africa, the team has steadily developed the enterprise, including the setup of an own lab that provides summary sequencing services in Ibadan. And we look forward to add other genomic services like next generation sequencing using biosequencers like we do here in Pretoria. As INCABA Biotech, we aim to contribute within our means to the science and economic development on the African continent, a continent that has a vast diversity and needs so much more equality. We have created more than 40 jobs at our offices in Nigeria, Ghana, and Senegal, and this will continue as the need for application in life sciences and diagnostic develop in West Africa.
Oh yeah,
Hello again. So now we reach the session 4, which concerns the practical sessions of this workshop. As you know, AfricaBP Open Institute organized different practical workshops through, in this case, through North Africa. So we have many practical workshops happening either here in Morocco or in other North African countries, including Algeria, Tunisia, Egypt. So I will be in charge of, with two other professors, Professor Narjis Shafei and Dr. Ishraq Hayah, for the practicals that would be happening here tomorrow, starting from tomorrow for over the next 3 days, which concerns the next flow pipelines. So I will be presenting that, and after I will give the floor to the other organizer for the other, either here in Morocco or in other African countries. So waiting to have the presentation. It's already here. Okay. So in what concerns the training that will be over the next 3 days here at our faculty, it concerns the next flow, AfricaBP and EI training workshop. So next flow, it resolves real problems in bioinformatics. People that have the habit to manage the tools in bioinformatics, they would understand easily that the main problems that we get is that when trying to solve a problem, we use many softwares. And the input of one software should go, the output of one software should go as an input of the other. And then often, we have many problems doing that with compatibility of different design of the softwares. And a lot of times is wasted trying to harmonize all this. To resolve these problems, scientists has invented many tools. Here, the case here is Nextflow. Nextflow, that is a workflow management system designed for reproducible results. So we can reproduce the same result, either I do myself or you do it. Either I do it in my computer or in HPC or any other cloud, so we will get the same result because it's something designed so to permit the passage from one step to another without perturbing the flow of the analysis. So what we will do during the next 3 days. So then the first day, we will try to present an introduction to Nextflow. What is Nextflow? So we will start, of course, by the motivation, why we should use, why we should learn Nextflow. And after, we will start by explaining the basics of Nextflow, including the channels, the operators, and we, of course, we will do some example to try to understand deeply. In the next days, we will go a little deeper in Nextflow by explaining the containers and the computer environment. And we will speak about a very important point, which is the configuration, because the configuration of the work in bioinformatics is very important because it's the step that will permit to us to precise which memory we'll use, which CPU we'll use, how we will analyze the data. So all could be harnessed at the beginning, so we will avoid a lot of troubles at the bottom of the work. And in the third day, which should be the most important one of the training, we will try to apply the Nextflow for real examples. And of course, we are interested in genomic and bioinformatic example. So we will try to use that for SNP call, which is an approach very used for all the people involved in genetics and genomics. And we will apply that to RNA-seq2, to gene expression using the RNA-seq tool, and to some EI too. So briefly, we will try to apply all what we learned in the first 2 days concerning next flow by using real examples. So hopefully we will learn how to do an analysis easily in a reproducible way, and we can repeat it in another time with another person without losing any detail. So that's mainly the scope of our training. Hope you will enjoy it. So that's what concerns Mohammed V University. Now we can jump directly to the second training that will happen at Mohammed VI University by Professor Hiroki Taniguchi, which he is present with us, and it concerns the gene editing, CRISPR-Cas9 fundamentals, comprehensive guide to designing genome editing experiment in plant and animal biology. Welcome, Professor Hiroki Taniguchi. You have the floor.
Here.
You can follow here or there as you want.
That's great. Okay, thank you very much for the great introduction, Professor Badawi. As he was mentioning, from here, we are talking about the workshops like from UM6P. In my case, like we are working on the workshop regarding CRISPR-Cas9 fundamentals too. Why it's two? Because like the last year, we were successfully introduced CRISPR methodology to about 10 students because we are doing like a lot of wet lab work. So we have to limit the number of the participants. And this year, again, we came back to African BP project and then to co-work with the project. And then this workshop is led by Professor Valentine and me from African BioGenome Project. So as Professor Badawi was mentioning, we are touching the genome editing using especially CRISPR-Cas9 system in the gene edit of plant and an animal species. And this workshop is held from tomorrow to the Friday for 3 days.
You have to pass the slides. Oh. The first one.
Okay, next slide, please.
You can use this.
Oh, this one? Oh.
Yes, yes.
All right, okay, thank you. Sorry. I was moving my laptop, but this one was not moving actually. Sorry for that. Actually, we are working on the gene edit, as I was saying, plant and then animal biology field. And as you know, probably very well, so this is the framework of CRISPR-Cas9 mediated gene editing. So basically, you use the guide RNA, which is composed by cRNA and trace RNA, and to target the editing DNA, or the DNA which is targeted for the edit. And once actually you have this complex to the DNA target, you have the double strand break, and after that you have the choice of the removing the target region, or if you want, you can replace the targeted element with the DNA that you are interested in to study. And after that, normally functional analysis is done. In the case of plant, we make the plant which are genome edited. In case of animals, we have not yet reached to this point, but some of the research in the world show that this CRISPR-Cas9 technique is used in several animals. And, so like the last year, we could only take 8 students because our laboratory scale, I mean, like the scale is not dynamic, and also like professors are limited to teach. And also we are highly focused on the wet lab workshop. So unfortunately, we can deal with like 8 to 10 students, but we focused on the young scientist, PhD student, and even master student to learn this CRISPR-Cas9 mediated gene editing. So hopefully they can get a good point of the genome editing. So when it comes to the detail of the workshop, the first day, of course, we introduced like a general role of CRISPR-Cas9 mediated gene editing, how it works, and also what we will do like in the class and so on at the really beginning, which is explained by Professor Valentine and me, and followed by several young scientists from African Genome Center. And after that, we talk about general way how to design the guide RNA, which I mentioned. This is very important element for CRISPR-Cas9 mediated gene editing, which can target the DNA to be edited. And after that, we're going to separate the students in 2 groups, and one will be working on cloning-free CRISPR method, which doesn't need to do any plasmid work, which is very easy. And you just buy the synthesized guide RNA from companies, and then mix with Cas9 protein, and then target the DNA. And the second one is the plasmid-based guide RNA, genome editing. So normally when you do genome editing, you need to produce the guide RNA. Normally, many people do this like using plasmid, which need to do like some cloning. So in this workshop, we focus on the training of how to clone the guide RNA into a plasmid and how to amplify it and how to be used. So because of the time limitation, we don't do actual final genome edited plant or anything, but we really follow the process from how to make the guide RNA to how to clone them and how to be used and so on and so on. And this first date, we do the start of the cloning-free method, which we require to do PCR and cleavage assay to do the targeting of the DNA by synthesized RNA in case of cloning-free method. And in case of plasmid-based method, we do ligation, which can allow the guide RNA to be into the plasmid. And second day, we do, because of we do like cloning-free DNA method related cleavage assay. So on the second day for the cloning-free method, we do confirmation of the result, because when the DNA is targeted by CRISPR-Cas9 mediated gene editing, when you mix DNA, PCR product that is coming from DNA, with guide RNA and Cas9, you can see the cleavage in the target DNA. So basically, instead of seeing like one single band, you can see 2 bands in your result. So we try to confirm this like with the student. And in case of ligation plasmid cloning based CRISPR, we do like cloning of the guide RNA, as I said. So we do ligation and then transformation into the bacterial cells. And then we reconfirm the result on the third day. And during the course, we do a lot of also bioinformatic related tasks, like in the field of CRISPR, such as simple blast search and how to make the guide RNA using several bioinformatic related softwares. And at the end of the second day, we try to sum up the result from the point of the student. So we let the students to make the presentations, and then we make the discussion. And the third day is like kind of very exciting day. We successfully get the sponsors from different companies which are really working on the field of CRISPR-Cas9 mediated gene editing, such as Thermo Fisher, Eppendorf, as well as GeneScript. So we have online seminar series, but we mainly focus on the practical aspect. So hopefully you can join in this seminar. I think the link will be like released very soon, and I hope that many of the people who are interested in CRISPR-Cas9 mediated gene editing can participate in it. And on top of that, since I have seen like so many cases when we were doing like workshop previously, some of the students are not that much familiar with pipetting, but like for molecular biologists and geneticists, sometimes like how to deal with DNA, how to deal with the enzyme, which is very important. So with the help of Eppendorf, we'll have 1 or 2 hours of the lecture, practical lecture in terms of the pipetting to make sure all the participants can do pipetting perfectly. And this is it. So we also have some supporters like from African Genome Center. And this is the end of my introduction, and thank you very much.
Thank you very much, Professor Taniguchi, for giving our students this opportunity to learn about gene editing. So now we can jump to the next presentation of practical sessions. It concerns a presentation about annotation of repetitive sequence transcription factor identification in plant genomes, which will be given by Professor Ashraf Lallali from Bioinformatics Lab, College of Computing, University Mohammed VI at Ben Gurion. Professor Lallali, you have the floor. Could you hear us, Professor Lallali?
Now you can hear me.
Yes, good. We hear you.
Sorry, I could hear you, but I was muted. And now sharing is not turned on. It's fine if you want me to present without some slides, but if you can, I can do that too. Can I share?
Yeah, you're a co-host now, Ashraf. Please share.
Sure, yeah. Okay, so thank you. I'm just going to give a brief introduction about what we will do tomorrow for those who will be joining us tomorrow at the Bioinformatics Lab at UM6P. So the title of the workshop is Annotation of Repetitive Sequences in Plant Genomes. And this is in a way similar to what we've done last year, but we are adding now annotation of transcription factor as we have developed a new tool since last year in this, and we would be happy to have you use it tomorrow or in this workshop. So the objective is to enhance the researchers' understanding of repetitive sequence annotation. So if anybody knows about genome analysis, once you sequence the genome and assemble it and you want to annotate it, one of the main issues is that you have to deal with repetitive nature of plant genomes. So you have to mask these regions, you have to annotate them, they have different purposes and reasons. So we concentrate this whole workshop on understanding what repetitive sequences are, the different types of repetitive DNA, and then how can we annotate them, how can we mask them for certain ones that we mask for this further analysis and further annotations that are required. And as I said, this year we'll also be adding transcription factors because they are very important elements, genes in plants. And we will be using some of our in-house tools to do all of this. The participants will gain both theoretical and practical knowledge. So we will have more in sessions where we will lead lectures. It's a small group, so these lectures will be very, close to the participants. So it won't be like your typical lecture room in a classroom, but it's more close with the lecturer. And then in the afternoons and sometimes even half of the mornings, we will have practical sessions about the tools we talked about in each lecture. Key topics would be introducing repetitive sequences in general in plant genomes, transcription factor identification and classification, and then we will discuss all the different tools and pipelines for annotation, things like repeat masker, Mega SSR, Mega Plant TF. These are our in-house tools, and among many others that we will cover in these 3 days. We'll have a case study on plant genome annotation, and we will also end with a future direction and how AI and standardized databases are helping our efforts in genomics. Day 1, so we'll have lectures about introduction to repetitive DNA, repeat annotation strategies, and then we'll followed by a Linux primer. So because a lot of these tools have to be installed in Linux, we will introduce the users to the Conda environments, what are Conda environments, how do you install them. This will make life much easier of somebody who wants to do bioinformatics, but not necessarily computer scientists. So we will have a 2-hour Linux primer, and then in the afternoon, or an hour and a half, in the afternoon, we'll have a hands-on exercises on repeat modeler and repeat masker. This will be done by myself, Dr. Imna Willi, and Mr. Zakaria. Okay. Day number 2, we will have in the mornings again lecture about SSRs as sequence repeats, simple sequence repeats, and how they are used in marker developments, and then followed by transcriptomic factor lectures. And then we will have 2 different hands-on sessions, one for transcription factors. We will see how getting them using the typical BLAST approach, and how our in-house tool, which is called MegaPlant TF, makes this use of AI to do this. This is the first AI-based tool to do transcriptomic factors, and the users will be able to, or the participants will be able to experience with this tool, as firsthand. We will follow that with another hands-on for SSR marker design. So not only finding the SSRs and classifying these SSRs, we will also do, use our Mega SSR tool that allow, the user, the participants to see how they can use these as genetic markers. And I think this was the favorites of last year's, so we kept this. Last year's participants really loved this part because they were able to find their own marker that could differentiate between different plant genomes that we have given them different plant genomes, and they were able to design their own markers and visualize the through in silico PCR, the PCR products to see that this marker really works for them. This will be done by myself, Professor Murad, Mukhtar, I forgot his name here, and my PhD student Asma. Day number 3 will concentrate that on transposer elements. So in general, so transposer elements, whether they're LTRs, whether they are transposer elements in general, and we'll experience with Mega LTR, which is our in-house tool, and also our plant LAI, which uses, which is a tool that we have created to measure how good an assembly in a plant genome. These are very highly used, one of our mainly highly used tools in our platform, and we will be sharing with the participants how to use these locally on their own on the lab computers as well as on our web services. And then in the afternoon, we would have, since it's typically students or participants come from far away, we will have an optional session about introducing all the other tools on our platforms that are not necessarily related to annotations. We will introduce them to the suite of tools that are available in the GM6P bioinformatics platform. Okay. So different tools that we will be using, I think I've mentioned some of them, for the sake of time. Do that, and then we will discuss as we go how we are, how are each of these tools are easily transitioning now towards integrating machine learning for improved annotation, developing standardized workflows and databases, how collaborative platforms such as the one they will be using helps genome research and specifically genome annotation research. So that's it for me. See you tomorrow. I'll leave you with some pictures from last year's workshop, and as well as my contacts and our website if you have any questions. Thank you.
Thank you very much, Professor Lalali, for suggesting this very interesting training. I'm sure that students will benefit a lot from that because we are in need for such kind of training. Thank you very much.
Thank you so much.
Thank you. And now we have to jump to the next presentation. I don't know if the okay, so we'll start with Pasteur Institute in Tunis. Okay, good. So we, Tunisia will be responsible for training or product. So it's next flow too in Tunisia. Okay, so welcome Dr. Farah Zemzem, so that he will take in charge the presentation of the training in Tunisia, which concerns reproducible bioinformatics with Nextflow applications in omics. Please welcome with me, Dr. Zemzem.
Sorry, Wabid? Professor Biabid?
Yes, I hear you.
Yeah, so I was thinking, is a Fatma on the, or was it switched?
No, he will speak on behalf of Fatma. Dr.
Okay, I think Fatma is online here. Okay, all right, okay, that's fine. I think Fatma is online. So Fatma, do you want to? Fatma Gwefali. Yeah, do you want to? Okay, go ahead, Zemzem.
Hi everyone. So I just need to activate to share my screen.
Okay, let me make it a co-host then. Okay, you should be able to share your screen now.
Yeah, thank you. Is it visible?
Yes, please carry on.
Thank you. First of all, thank you for this opportunity to share knowledge and to be engaged in such community. So today I will go through the workshop that is usable in bioinformatics, which with Nextflow application in omics. Of course, our thanks goes for Nextflow, our community, IPT, the Institute of Pasteur, Tunis, and the Africa BioGenome Project. So this training will be led by me, Fida Zemzem, and Hussein Din Othman. We are representing Nextflow, and we are the Nextflow ambassador in Tunisia. We hosted only 18 participants because our main goal was to promote knowledge and knowledge sharing, and also collaboration in the classroom between all members. So these participants just was selected fairness among all participants and all members. Just it was based on qualification and interactivity. So just for learning purposes. So why does this matter for us? Why this Nextflow does for me as a biologist, and for you, for all, even if you are not a biologist, why this matter? Okay, we will talk just about the reproducibility, and before we dive in the workshop detail, let me set the stage. Unfortunately, we are somehow in the reproducibility crisis. You can notice this as biologists. Many scientific results cannot be reproduced, even if you are trying to repeat and replicate your data. So the same stands for Nextflow and for different pipelines. That's why in today's fast-paced, of course, with development of bioinformatics and data analysis with a huge amount of data. Developing a pipeline isn't just a convenience; it becomes like an essential an essential blood lie for the new genomic area, for the new coming newbies, and also. Codes lives more than we do because this is an important argument, because you write codes not just only for you or for your colleagues, for your team. It will be accessible and it will serve the next generation. So in this training we have 3 days. And the 3 days will start from initial steps. So we will start introducing the reproducibility crisis and omics analysis, of course, detailed manners with the real cases example. And of course, in the day one, we will manage how to install, how to set your computer, your computational power, of course, pipelines, principle, execution, and all these details. Of course, the second day will focus effectively on how to manage input, outputs. So how to deal all these data, all these amount of data, and how, of course, how to perform your analysis steps, how to deal with containers, and why the reproducibility again matter with codes, just with codes. Of course, the best practices for sharing workflow will be also introduced. And in the final day, we will go through more in NF core pipelines and the difference between Nextflow and NF core. it is a little bit the same, but it isn't. So no more black box. You will understand how it is running, how it is really developed. So you can manage, you can manage, you can deal with other codes, you can produce, you can repeat, and also develop. And thank you.
Thank you very much, Dr. Firas Zamzam from Tunisia, for suggesting next flow training. I think it's a very good opportunity for students in biology and in others to learn how to reproduce the results. I think it's a very important theme. For that, it was chosen to be in two North African countries, Morocco and Tunisia. Thank you very much, Dr. Zamzam.
Thank you again.
We can now jump to the next training. It concerns Algeria, and it concerns, we have practically 4 practical workshops, themes, that will be presented by Professor Suhail from Tlemcen University. Please welcome with me, Professor Suhail.
Thank you, Professor Badawi. First of all, thanks for this organization, for this event, important event in Africa. Thanks a lot to give us this opportunity to present our workshop. So I present just the 2 workshops are organized by University of Tlemcen. The 2 others workshop, I don't have a presentation for them, but
you can just say some words, Suhail, just 2 or 3 words about what, that's all.
Okay, no problem. I can share my slide with you.
Yes, please, go ahead.
I don't found just a minute.
Take your time.
It's shared?
Yes, just make it full screen, please. Perfect.
It's good like this?
Yes.
Bismillah ar-Rahman ar-Rahim. Hi, everybody. So I have pleasure to present you the workshop we done in Algeria. As is said by Professor Badawi, we organized 4 workshops in Algeria. One in Oran is done in a private society called Genetical, is about bioinformatics and NGS technology. The second one is organized in University of Ain Timousent and is concerned SIG approach to identify plant. The 2 others workshop is organized in University of Tlemcen, and I directly coordinate these 2 workshops because it's done in my university. The first one is entitled Practical Workshop on Small Remnant Morphometry, DNA Extraction, and Practical Statistics with R and RStudio, is presented by Dr. Belharfi Fatima Zahra. The second one, the partners. Excuse me 1 moment. You see the screen? Oh,
We see the page in which it's a written practical workshops on small ruminant morphometry.
You see the screen now? It's clear?
Yeah, we can see, yes.
Because
it's the first slide.
Yes, okay. I don't find it here. Yeah. The second one, oh, not possible. The problem, I don't found it in my laptop. I don't know why this. Okay. The second one is called the morphometric analysis using morphogene and DNA extraction of insects. Case study Apis fabai, presented by Dr. Salah Zahra. Africa represents 6% of the surface of the Earth, is rich, as you know, in diverse biological resources, is a paradise of biodiversity. Unfortunately, there are structural crises and depletion of forest resources. So the solution is conservation and sustainable use of resources by encourage conservation, promote better use and better sharing. The tools using to do this is morphological study, especially in this time when the genomics tools are developed. There are return to phenotyping became very important. Morphological characterization remain essential for accurate species identification and classification, especially in environments where critic species or frequent hybridization occur. Integrating traditional morphological data with genomic information enable a more comprehensive understanding of evolutionary process, adaptation, and species diversity. Morphology guide the collection and verification of boucher specimens, which are critical for validating genomic dataset and preventing sample misidentification. High-resolution morphological data support the interpretation of genetic variation and phenotypic plasticity revealed by next-generation sequencing technology. And I think the more important point is gene identification through GWAS. Why we present two workshops, DNA extraction on different species? DNA extraction protocols are highly dependent on species-specific anatomical and biochemical characteristics. A protocol optimized for one family often fails to deliver sufficient quantity or quality of DNA for others due to difference in tissue hardness, secondary metabolite, or cellular structure. Biological inhibitor or endogenous nuclease may degrade DNA or prevent successful downstream analysis if not addressed in the protocol. Effective extraction frequently require protocol modification, altering lysis condition, buffer composition, or purification step for each taxon. Success often relies on extensive trial and error or published optimization specific to each family, even each species. Adapting protocol improve DNA yield and purity, enabling robust downstream application, including next-generation sequencing. Emphasizing protocol adaptation raises awareness among researchers that DNA extraction from diverse taxa is critical, often underestimated factor for the success of genomic project. The first workshop concern sheep and goat is divided on three parts: morphometry of sheep and goat, DNA extraction, and practical statistics with R and R Studio. So ensure knowledge of phenotypic characteristics is important. The identification of population using descriptor of morphological and geographical distribution is the first step in the characterization of genetic resource. Body measurement from the basis on the scoring table within a given breed. Moreover, some of them serve as bases for estimating live weight, which allow the monitoring of fact cover, the determination of a dosage in medical treatment, the monitoring of growth. The morphological characters start by a good sample representing correctly the population studied, choice of the character, especially mentioned by FAO guideline, and morphometric characterization. The practical statistic is done with R and RStudio. These two software are for free and are the common software using actually in genomics. DNA extraction technique practical is done on salting out extraction for goat and sheep, because this technique does not use organic reagents such as phenol or chloroform. Digested protein are removed by salting out with high concentration of NaCl, but there are some problem in this technique because if it's not done correctly and specifically, we can have problem with contamination. But this technique is good because she can done a great quantity of DNA. Second workshop is done on insect. We are, as you know, in entomology actually and systematic is influenced greatly by morphological characteristic, metric and meristic characteristic. Comparing the anatomical characteristic of organism and understanding how variation in these characteristics is associated with variation in other trees has long been of interest to ecologists and evolutionary biologists. The plan of this workshop concerns introduce participants to the principle of geometric morphometrics and their relevance in insect systematic and population studies. Teach participants how to collect, organize, and process landmark data using software tools such as TPS series. Demonstrate how to import and analyze morphometric data set in morphology, including interpret morphometric result in the context of intraspecific variation, sexual dimorphism, and geographic differentiation within Apis fabae. Train participants in insect DNA extraction technique using commercial kit or classical setup methods, also using to extract DNA in plants. This detail, I think, is good. So in this workshop, the participants show demonstration in TPS util, load multiple TPS file, organize data set, export to morphology, import image plus homolog landmark, and okay, import data, procrust alignment to do PC and Sevilla, visualize cluster the deformation grids, collect and preserve sample, tissue lysis, DNA purification. Use in species. So this DNA is used in species identifications, to the genetic diversity, complement morphometrics. And thank you for your attention. And sorry if I go more than 10 minutes.
Thank you very much, Professor Suhail, for the coordination of all those trainings. I'm sure they will be of great benefit to all the participating. Thank you very much, Suhail.
Thank you, Badawi.
Now we jump to the next training. It concerns Marine Bioinformatics Hackathon, Biodiversity, Genomics, and Next Flow Pipelines, which will be presented by Professor Asma Abu Shadi from the Biotechnology School, Nile University, Egypt. Please, Asma, you have the floor.
Professor Suhail, could you please stop sharing? Professor Suhail, please stop sharing your screen.
Suhail, you are always online?
Okay.
Yes, I'm
Hello,
online.
everyone.
I'm online.
Suhail, tu peux arrêter le partage de la présentation?
J'essaie de l'arrêter, mais j'ai pas trouvé où l'arrêter.
Bah, tu fais échappe, je pense.
Il me donne seulement partager. Il me donne pas la main pour
Là,
arrêter.
tu cliques sur l'échappe de l'ordinateur.
Yeah, I think Asma is sharing now.
It's okay. Suhail, c'est bon, c'est fait. Merci beaucoup.
D'accord. Merci à vous.
الله يحفظك.
صحيت الله يحفظك. شكرا.
Hello, everyone.
Hello.
Hello.
We can hear you very well, Professor Asma. Go ahead.
Okay. Thank you, Professor Bouabeid. Good afternoon, everyone.
Good afternoon. We can hear you.
Okay. Thank you. It's my honor to be here. First of all, I would like to thanks to start your video. Okay. Okay. Again, thank you for your invitations. It's my honor to be here for the opportunity to present our workshop and the key highlights of this year organized practical part of the North Africa regional workshop in Egypt, and gave you a brief overview of my university, which hosted this year's North Africa Regional Workshop. Okay, I'm Asma Abu Shadi. I'm Vice Dean of Biotechnology School and the Program Director of Undergraduate Program of Biotechnology, Nile University, Egypt, Cairo. Okay, I can't change the slides. Why? Yes. Yes. Thank you. Okay, this year and for the third year in a row, we are excited to collaborate with the African BP team to organize and host the North Africa Regional Workshop. This year, our workshop entitles and will be focused on marine bioinformatics hackathon, biodiversity, genomics, and the next flow pipeline. As I mentioned, it will be hosted in Egypt by Nile University, and I will take you in a brief in our institute. Nile University is the first national non-profit university in Egypt, and we all aim to be a leader in technology and business education in the MENA regions. And we have a vision is to be world-class institution with significant public benefits, and our mission to focus on excellence in learning and research and innovations. Nile University is the first ranked in the number of published research per faculty members, and the first one among private and Ahliya University in Egypt for excellence in international publication award by Egyptian higher ministers. Okay, let's dive into our workshop topics to go through our agenda. As you know, the biotechnology or marine biotechnology is a specialized field that focused on the potentials of marine and aquatic organisms for the technological applications. And also it plays a role in a number of areas, including food products derived from marine and source of bioenergy and bioactive component with pharmaceutical potentials, such as antimicrobial or anti-inflammatory or anti-cancer drugs. So we are focused in our workshop, the practical part. We focused on the marine biotechnology, as I mentioned, and let me introduce our incredible team, Nile University team. We are honored to collaborate with Professor Dr. Abdullah Sharaf as a senior bioinformatics of Constance, Germany. Constance University, Germany, and a professor for Ain Shams University, Egypt. And also we are honored to collaborate with Professor Dr. Sameh Hassanin. He is a program director for bioinformatics majors in Nile University and senior of bioinformatics group leaders in our NU and Nile University, and my colleagues Asim Adri and Mrs. Shaima Rujdi is assistant lecturers in the School of Biotechnology, Nile University. As I mentioned, we are in the third wave or third year for hosting and to collaborate with the African BP team. We starting from 2023 to until now 2025, and we are focused as a part of our effort to raise awareness about the African Genome Project and the important for the bioinformatics tools and the new techniques in this area. And we to make it real, we have a philosophy for to help the young researchers. So we organized. We have about 37 applicants confirmed. About 90% of them confirmed to attend our next 3 practical hands-on in Egypt, in Cairo University, as I mentioned, and we try to help to provide all support and all scientific consultant for our applicants. So we organized small working groups for those applicants to work together for their own project and to deliver the consultations and support all of them for their project. For the next 3 days from tomorrow, we have a condensed agenda divided to 3 days. The day 1 focus on biodiversity loss and the metagenomic strategies, next gene technologies, 16S and the metagenomics strategies, Galaxy. We go through Galaxy tutorials and sequence alignment. In the next day, our second day, we will be focused on coral metagenomics and metabolomics and visualizations and biodiversity genomics and hackathon kick-off. Sorry. In the third day, which is a very, very important day, because we have a small project. We organized, as I mentioned, a small working groups for all applicants, all participants. We will assign a small project activity for them to be ensured that the possibility of applying what they have learned through the past 2 days and make it use all the techniques and the tools which they learned in the past 2 days. And what is new in 2025 for our workshop? We are full integrations of workflow management tools, Nextflow, and we have a lot of hands-on hackathon fostering teamwork and creativity, and the data driving case study. The students will work on the real case study visually physically in our campus. In the marine biodiversity, and all the data digitalized sharing using the link GitHub. So all participants, they have all materials, all sheets, or methodologies that we will teach all of them. And as I mentioned, we are have a philosophy for the project-based learning, and it's very, very important tools to teach our young researcher for the new techniques. As I mentioned before, we have 3 days. We will start tomorrow, the timeline from 9 Cairo time zone to until 5 p.m. We have mixed for theoretical lectures and practical sessions under supervision of our professors and our colleagues. Dr. Sameh Al-Sayed and Mrs. Shaima and Mr. Asim. And in the next day, as I mentioned before, we will be focused in the practical for extraction and the taxonomical informations and the visualization, etc. As I mentioned before, we will divide the groups. We will help the students. They will take the project to work on it and discuss in the 3rd day for the closing session. We have a slogan in this year, and we are dedicated to making this a workshop where knowledge meets practice and transforming the capacity into impact. Thank you for your attention. It's my honor to be here to present what we planned in Egypt, inshallah. Thank you.
Thank you very much, Professor Abu Shahdi, for this interesting training concerning marine bioinformatics hackathons. So in name of AfricaBP, we thank you and your institution. Thank you very much.
Thank you.
We jump now to the next training. It concerns exploring genomic diversity, hands-on workshop in plant genome sequencing and bioinformatics, presented by Dr. Mai Barakat from American University in Cairo, Egypt. Please welcome with me, Dr. Barakat.
Hello, everyone. Thank you, Dr. Bobby, for this kind invitations, and I'm really happy to be here today. I will start to share my presentation. Is it okay now?
Yeah, perfect.
Okay. So I'm truly honored to present on behalf of the American University in Cairo, School of Science and Engineering, highlighting our role for the first time with the North Africa African BioGenome Project for wet and dry lab workshop for the first edition in our school. So over the past week, we have had an exciting journey combining hands-on genomic experimentations and computational analysis, building capacity for learning the biodiversity genomics in the region. Before diving into the workshop outcomes, so I would like to briefly introduce our institutions. The American University in Cairo is standing at the bridge between Africa and the world, with a strong focus on scientific innovations and interdisciplinary research. So our School of Science and Engineering hosts over 2,400 students, and more than we have 150 labs and 100 departments, all accredited by top international bodies. So please feel free to visit our website also to explore more about our programs. Going to the research at AUC, research is central in AUC identity. So if we can talk about 2024, our School of Science and Engineering received around 34 new research grants and contributing to hundreds of publications across diverse disciplines, as well as high record of citations. I think we have a strong infrastructure and advanced sequencing platforms and dedicated expertise. AUC continues to foster collaborations and that drives impactful research in genomics, sustainability, and One Health. Now let's go and dive into the main of the workshop. For the first time, we host the African BioGenome North Africa Regional Workshop, Wet and Dry Lab. It was held in from October 19th to 23rd. And we hosted around 15 participants. Short selected across Egypt and other neighbor North Africa countries. So the workshop was divided into 2 tracks. One for wet lab for 3 days and DNA extraction, quality control, and sequencing preparation. And for dry lab, it was focused on bioinformatics pipelines and genomic data analysis. So our shared aim to build colon-based methods, and we discussed about the different methods for plant extractions, including the CTAP, the standard one, is sorry. So we emphasized the importance of the DNA quality as a foundation of for every sequencing project. The participant used the nanodrop cupid gel electrophoresis to assess the quality and the purity, concentration, and the integrity. So throughout these exercises, the teams learned how to produce high-quality DNA sample, and for sure they learned about the troubleshooting to be suitable for library preparation and sequencing to the Illumina MySeq platform. So going to the dry lab achievement, following the hands-on for the lab work, we transitioned to the dry lab, coordinated by our lovely doctors Roba Hamed and Rana Khalil. So they focused on to empower participants to manage and interpret the sequencing data, bridging the gap between the bench and the bioinformatics pipeline. So the participants were introduced to Linux-based computational environment and setting up their own system using Windows subsystem for Linux and Mac OS terminals using our computers. They learned to create a Conda environment and install key informatics tools like FASTQ and BCF tools. The group worked in database Arbutus thaliana, and it's a Moroccan variant plant, and they compare between the African strain, the Moroccan one, and non-African reference from Colombia. So to explore genetic diversity and the variant calling. The sessions cover essential data from it like FASTQ, SAMBAM, and VCF, and guided participants through a complete variant calling workflow. From the read alignment to SNP identification and annotations. This exercise gave the participant for the first-hand experience in analysis the plant genomic variations and interpretations results using publicly available databases. And the end of the workshop, we distributed the feedback surveys to all the participants to see what is the feedback, so we can improve also the workshop for the next year, as this is for the first time to host such workshop. So the feedback was received was overwhelming positive, alhamdulillah. So participants highlighted the hands-on integration between the wet lab and dry lab sessions as a particularly valuable, and many expressed confidence in applying these techniques in their own institutions, demonstrating how the African BioGenome training models directly build sustainable research capacity. So the last slide is just one to acknowledge everyone who was participating in such workshop. It was really a very nice and lovely team. It was a long week because we have 5 days. So I would like to thank first the African BioGenome leadership and the organizer for their efforts and coordinations. And also I would like to thank AUC organizers and our department support and HVD team. So thank you, and I would like to give the floor to one of our technical support at HVD to talk about more about what our participants have learned about from the Illumina platforms. Thank you.
Thank you very much for my barakat for this interesting workshop. And thank you in the name of AfricaBP. Thank you very much.
Thank you.
Professor Boabi, I don't know if Professor Mai Barakat says someone wants to talk. Did I get her correctly?
Say it again, thank God.
It looks like Professor Mai Barakat, did you say someone from HVD wants to talk? Okay, is that Ahmed Mahib? Okay, let me make you. Boabi, yes. Do we have Professor Boabi? Do we have time?
How much time?
Okay, so yes. Ahmed Mahib, can you make it very quick then?
I remember. Yes. Mai asked for that before. Yes, of course I can go ahead. Yes.
Yeah, sure. Right. I will make it so fast.
Yeah,
okay.
All right.
Just let me share the slides. Tell me if you can see it now.
Yes, carry on, please.
All right. First of all, I would like to thank you for the room to let me talk, and I would like to thank Dr. Mai Barakat and African BioGenome Project and the ASC for sure, and the ASC team. I'm talking on behalf of HVD Egypt, and who is HVD Egypt? We are the channel partner or the distributor for Illumina in Egypt. And actually, we love this job a lot, and actually we have supported with HVD, with AUC to support with the workflow and to make them work more better with our workflows. First of all, what we have delivered sequencing by synthesis overview as an overview for sequencing by synthesis by Illumina. Firstly, from how the fragments are made, how the library preparation are made, what is the adapters, what is the flow cell, and what is happening inside the flow cell. And if we zoomed in, like the photo on the GIF on the right, we can see that what happens in the device. The next part, we have talked about the library preparation overview and how we prepare our fragments or our DNA or our sample to be compatible with Illumina platforms, MySeq platforms especially. Then we have used the Nextera XT DNA library prep. We have talked about the chemistry, what is the transposons, how the transposons cut and adding the adapters at the same time, and what is the chemistry and the science behind this kit for DNA library preparations. The third part was Nextera XT DNA library preparation steps. We have talked about the general steps for library preparation, like segmentation, genomic DNA, what is amplification libraries, how to clean up the libraries, how to normalize, how to pool, etc., and how to talk about the concentrations and what is the equation to make the normalization for each sample. And actually, this is not the only application for Nextera XT that to make whole genome sequencing for our sample or our plant or our microorganism. There's a lot of applications, including that applications that are presented here in this slide, like metagenomic sequencing, Illumina DNA prep for whole genome sequencing as total, UPIP, etc. And this is some applications using the Nextera XT and Illumina DNA prep like 16S and shotgun metagenomics that would be beneficial for our genome project, as I thought. We have talked about the MySeq system features because this device that present on EC, the MySeq system features, what is the optical bench, what is the reagents, where is the waste container, etc. And what is the reagents and sequencing reagents used for sequencing using Illumina platform like this that presented here in this slide. Then we have created a run, and we are we have talked about how to create and how to run our samples inside our device. And this is the Illumina sequencing systems, and we have talked about the differences between the different systems by Illumina and when to use it and how to use it. If you are using a focus tunnel, if you want a flexible power, if you want a production power, if you want a population power. Then this is some unforgettable moments from the batch of this workshop. It was amazing, actually. And at last, I would like to thank you all and thank Dr. Mai Barakat and everybody here.
Thank you very much, Dr. Ahmed Mohib, for presenting the services that Illumina HVD could represent. Thank you very much. And now we jump to the next, I think it's the last presentation, the last training. Zinab Rashid, yes. Okay, I will say some words about that. So we will present now the training that will happen at UM6P, sequencing Illumina. I will say some words on behalf of Dr. Zinab Rashid. Okay, so the training that will happen at UM6P, it's NGS sequencing, or what Dr. Zinab Rashid named it, hands-on training on Illumina workflow, Illumina DNPSF free library preparation for whole genome sequencing on NovaSeq Plus. Just to, you can go ahead, please. Thank you. So just quick reminder, Dr. Zinab Rashid is leading CoLab, which is quite the biggest genomic lab in our country and surely in North Africa. And the training will happen as presented here. During the first day, after speaking about this, the safety, The training starts by PCR DNA-free library preparation, after DNA quantification, DNA segmentation, the post-segmentation, the library validation and cleanup. So it will be quite the first day wet lab. For the next day, could you go ahead, please? Yes. So for the next day, after cleaning the library, the participants will quantify the libraries, and pool them and denature them, the libraries. So, and after, Dr. Shayed will explain the NovaSeq Plus workflow and prepare the NovaSeq kit and the flow cell, the patterned flow cell, and set up the sequencing for running. So after that, she will denature and dilute the samples and start the sequencing effectively. That's for the second day. For the third day, once the sequencing done, and we got the analysis, so they will start by analysis of the image and the base scaling, and by the NovaSeq run monitoring. And after the break, the participants will use the base space core app and the BCL to FastQ conversion. By that, they should finish the training. And at the end, some quizzes and wrap up of all the training. So that's very interesting training that concerns the NGS. I think the participants will benefit a lot from that. So that in what concerns the UM6P collab by Dr. Zineb Rashid. We have another training, this time from Tunisia, by Professor Nabil Ammo, who was not able to be with us. And it concerns from barcode to biosurveillance, hands-on species ID for biodiversity, and e-health using ONT barcoder 2.0. So we have not Nabil Ammo to speak about that, but just we would like to mention the training here. So we thank all the organizers of this interesting workshops. So now we will give the word to but we will have thank God and Professor Julian. Yes. Yes. I think we give the floor to Dr. Thank God Ebenter and Professor Julian, and later we can make concluding remarks and give the prize for the people. Dr. Thank God, could you hear us?
Yeah. Yes.
Yes,
Thank
we
you.
can hear you.
Yeah. Okay. So Thank God and Julian are with us. So please welcome Thank God and Julian.
Yeah.
Okay. So I think Professor Julian will go ahead and give his very short presentation.
All right. Are you with me? Can you see my slide?
Please carry on. Yeah. Make it brief so that.
Yeah. That's fine. Thank you very much, everyone. And you're welcome to this brief presentation. Will not take much of your time because time is already behind us. So I'll start it and thank God to follow up and tidy it up. When you see this global map, it shows biodiversity loss. The areas that are shaded red are areas with intense biodiversity loss, and the areas that are blue are areas that are close to it. House is a conglomerate of so many affiliate bodies like Africa BioGenome Project, Canadian BioGenome Project, European Reference Genome Atlas, etc. There are so many groups. And each one is working towards preservation of and conservation of biodiversity using genomics and the bioinformatics data. AfricaBP actually was established in 2021 and had a target of sequencing about 100,000 genomes of animals and plants in 10 years, generating approximately 203,000 gigabase of DNA sequence data. And AfricaBP considers as best approach the support of sequencing and analysis efforts in continent, that you get the species here, process and sequence them here. And where do we see this biodiversity of critical interest? In West Africa, each country has areas of urgent concern, deeper brownish red, are the areas with most intense threat to species, and then the lighter areas show less extinction pressures. For South Africa, you also have 3 major hotspots like the Cape Floristic region, which has extraordinary diversity of vascular plants, and we also have the succulent Karoo, which hosts nearly 1/3 of the world's succulent species. We have the Maputo land, Podoland, Albany corridor. Each is rich in a unique collection of flora and fauna. And having these, AfricaBP is interested in conservation of these species of concern. And one way we do it is through knowledge empowerment, because it's through training people and giving them the capacity to get these things done, that people can come into the sequencing, generating enormous digital sequence data, to meet with the mandate of AfricaBP. So here, AfricaBP has the Technology Development, Knowledge Exchange, and Industrial Grant Challenge, which offers us the platform for this knowledge exchange. And this is done through the Open Institute. The Open Institute of AfricaBP, is involved in capacity building through especially the fellowship, through fellowships, through our workshops, and then other forms of training. And the workshops is, the training is given at an international platform. The structure of the partnership utilized for the training is tripartite. You have AfricaBP on one side, you have the African institution on the other side, and then have partners and the institutions outside Africa, and corporate bodies on the other side. And each one has its own responsibilities. AfricaBP, for instance, stands as a coordinated Pan-African effort to build capacity, generate, analyze, and deploy genomics data for the improvement and sustainable use of biodiversity and agriculture. But the partners also have their own responsibilities, especially to provide funds, to provide the facilities for training, and help in other ways too, to make the fellowships successful. So far, we've had 3 very successful fellowships. The first was in African Genome Center in Mohammed VI University, Morocco. After that, through that program, we trained 10 people from 10 different nationalities in Africa, countries in Africa. Then we also I had another one at the University of Illinois in the US. And then the third one was with IIPA. And each training, each fellowship has a target of getting the people trained, and the people also having the capacity to write down what they have learned through that training and publish it in a reputable journal. This is one of the fellowships, and because each fellowship has its own criteria. For this, there are 4 criteria. 1, affiliation, the person must be from an African institution or organization and must have relevant experience and should be at any stage of the person's career, and then should actually be a African national. And the justification of the partnership are about 4, like to generate data, contribute knowledge to technology, contribute to knowledge and technology transfer, provide support for bioinformatics and genomics capabilities, and leverage on already existing partnerships. I wouldn't go through this one because much of what it has can be paraphrased in other slides. Now, each of the partners or the fellows, prospective fellows, institutions has a responsibility. For instance, the home institution of the prospective fellow should nominate a candidate and be ready to do some sponsor that candidate, especially locally, and develop curriculum and research programs in biodiversity, genomics, and bioinformatics, and help cover visa processing fees. The prospective fellow has his or her own responsibilities, especially to apply and follow the due process to get nominated. And the selected fellows also have their own responsibilities. And then sometimes the responsibility could include self-cover of the costs of the fellowship, especially areas where the existing cost does not cover. And then AfricaBP and partners also have their responsibilities for to provide scientific directions, call for applications and advertisement, and do advertisements, shortlist and select fellows, and seek additional funding where necessary. The funding structure is just what you have seen. It's simple. The African institution or Center of Excellence will take care of home tuition fees within, and the candidate is still within, the fellow is within the country. Accommodation costs should be taken care of, and research and living expenses also within the institution and the nation should be taken care of. And then AfricaBP and the partner entities also have their responsibilities, like the funding the fund costs of costs in countries of affiliation, the cost of research, accommodation, living expenses for the period the fellows are outside their countries. And then we summarize the expected outcome this way, the sport capacity building and academic mentorship, which is a very important target of AfricaBP, especially in genomics and/or bioinformatics in their home institutions. They should acquire capacity to design research programs in genomics and/or bioinformatics in their various institutions, and develop leadership qualities in genomics and bioinformatics needed to spur up and drive the proposed AfricaBP Open Institute Centers of Excellence. They should generate more biodiversity data for agriculture, agri-conservation, and biodiversity genomics. Yeah, I think at this point, Tango can round it up.
Yeah, thank you.
Much.
Thank you, Professor Julianus. If you stop sharing, that will be very helpful. Yes. So I think for me, I would normally be making a presentation. So do we have Professor Boabid on site? We're just gonna, yeah, I won't be making any presentation. I would just the next 5 minutes interaction, because I know we need to round up.
Yes. Thank God, I'm here.
Yes. Yeah. So I think so far we've this is the third time we're having the workshop in Morocco. Basically, generally we kind of have the workshop all year round in each region, and the North Africa workshop is rounding it up. And I think so far it's been fantastic presentation. I saw the presentation on the plant genome. I saw the presentation of from other countries coming to present in North Africa, in Morocco. We saw the presentation on the AI, LLM. Very, very fantastic presentation, and I'm actually looking forward to this metamorphosing into bigger things, particularly, and hopefully I hope from next year we can have more national genome projects being presented, for instance, from North Africa, from Egypt. Hopefully, I'm hoping that the Egyptian scientists can also have their own national biodiversity genome project to sequence, say, 1,000 or 100 or whatever amounts, and also can have the same in Morocco, and just as we have in South Africa and the rest. So I'm hoping that from next year there will be more presentations on that, where each countries also speak about their sequence genome. So it's starting gradually, as we saw from South Africa this year, and we would actually ultimately sequence all the genomes across the continent. So I would like to thank Mohammed V University in Rabat, and also all the presenters as well from my end. But just to kind of make this very interactive, on kind of open up the floor for 5 minutes on what direction people think we could potentially go in this workshop, in addition to all what has been happening, because I know that is an intense week, from Monday to Friday, so many things happening. This year we received over 1,300 applications, and out of this we can only train 100 people, for instance. So yeah, I think the floor is just open for 5 minutes. People can just comment, maybe go a bit from your end as well if you have questions. And
Okay, thank you very much. Thank God. So before going to that, I would like to maybe many people that don't know you here. Thank God is the heart beating of AfricaBP. I mean, he's working day and night to push things ahead. So I would like to thank him and really to congratulate him for all what he's doing for this project. I'm quite sure that without him, things could not go that far. He's pushing. When I say it, I mean it. I mean, he's pushing day and night for that. I mean, he's dedicating part of his life to this project. So thank you very much. Thank God.
Thank you,
I would like to thank Professor Julian too. He's working hard to push things ahead. Thank you very much. So in what concerns your questions, maybe I can ask some people to suggest something, but from my side, I think that students and early career researchers, they need more training. So maybe if we would like to focus on something or to change something in the next versions of AfricaBP, is to increase the number of trainings, or instead maybe of doing 2-day workshops and 3 days of trainings, maybe 1 day of presentations and 2 in parallel trainings or something like that. So people, they need trainings, but of course, solid trainings and trainings that make the change on the ground, because as we are all conscious, biology now changed. We do no more the traditional biology in which the biologists, they handle 2 samples and they get 1 sheet of information and they try to analyze it with simple tools. Now biology, it became very complicated, and now we can we can assert with a big likelihood that each student in biology has to do some massive analysis with sequencing and world data. So training in this case would be very, very beneficial to the students. That's what concerns the training. And what concerns, of course, the thing that we hope most to go toward it is to start our national projects. I mean, when starting our national projects, to have our data, to have our servers, and to involve the youth, the young researchers in that would be very, very good things to reach in the next year, if not the next years.
Yeah.
So that's my point. Now, if anyone from the people that are here could tell us what he would prefer to be, what he would like to have more than when we are doing during this week in the context of AfricaBP. So if you can share your opinion, it's very, very welcome.
Yeah, I think Professor Boabe, while we wait for people to comment, I definitely agree that the 2 comments you made, training and project. So I think the national project will really kind of increase the training. If, for instance, if we train more people, then if they have a national project they could work on, then that makes it easier for them to retain the training they've gained. And I must say that each year we train 400 African researchers across the regional workshop. Since 2023 that we started, by this Friday, we would have trained 1,200 researchers. So our aim is to increase it. If we can increase it to 10,000, even 10,000 is too small for the continent, I must say. So so we have in plan to actually potentially, because we don't want all researchers to come in one location. We want to be able to have multiple practical sites in each country. So hopefully that is one of the things we'll look into this coming year. And more importantly, we want more national projects to come on board. We want Morocco to start their own national biodiversity genome project. We want Egypt to start, Tunisia to start, and all the national projects on the continent. And to do that would then kind of help increase the benefit of the training. One will also help inform policy at the national level, and also innovation and scientific successes that comes with all of those activities, both in food and in conservation. Yeah, I think I definitely agree with you, Professor Boabi.
Thank you.
Please, I also want to add, especially with regard to the training, we actually need sponsors of fellowships. Fellowship is a major avenue of training people. And when people have fellowships, they don't just train for 3 days. They have a good number of days to stay on the job. Apart from the main work, laboratory, the wet lab work, they also learn the bioinformatics part and then the writing part. The knowledge is enormous. And when people are so well trained, the people can actually serve as extra hands to train more people. So that is one way we also increase the knowledge. And we encourage people who have the resources to support our fellowship programs. And through that way, we can train more people that will train others, and then the knowledge spread will be quite fast. Thank you.
Thank you, Julian. Just I would like to add, according to my experience and the experiences of many colleagues I know, sometimes it's not the training itself that changes the person. Sometimes that when you do the training, you discover that you love something very much, or you are influenced by a person. So I think that things could change all your orientation. For that, the training is very important. It has not to be really some heavy training. Sometimes just the right subject, the right person, it makes the early research career with students change all his orientation and open for him new door that he didn't know before. I think, Salah, you have something to say? Go ahead, please.
Right. So based on my experience throughout this series of talks, I really understand that it's very important to leverage our continent and to leverage what we have in terms of resources. I think that it's a very zero-sum game where a lot of African researchers, whether they're young or whether in their intermediate stage of their career, they always just look forward to starting a fellowship abroad or finding an opportunity in Europe. I think we don't genuinely invest in Africa in an honest way. I think that when a project is in line, when there is financial gain to be made, that's when we're interested, that's when we're on board. But I feel like there needs to be a sort of social sensibilization. There needs to be this injection of knowledge into the youth that it's okay to stay local, that it's okay to stay in Africa. And in fact, we are the people who are going to pull humanity forward. It's not us always who have to go towards Europe. Why not them come to us, especially in terms of national resources, in terms of genetic and genomic and biodiversity richness? It's we who have that. We shouldn't always rely on others to provide to us what we already have. So breaking that chain of scientific colonialism is very, very important, I feel. And that's what's going to be the genesis of a scientific Africa, of an Africa that actually cares about itself genuinely and doesn't always obey what so-called leaders in industry say. So that's what I feel potentially the project could veer off into, sensibilizing Africa and young Africans, north, south, east, west, however, to try and invest in the continent genuinely and not take the bait of a European or American or whatever research grant. It's better to stay local, and creating programs that encourage students and young researchers to stay is very, very essential. And even starting from a high school or primary or secondary school approach, showing everybody that young Africans, showing them that Africa is rich and that it has a lot to offer. That's very, very important. And potentially a junior AfricaBP project could be enacted to have even younger people participate. And that's what I honestly and genuinely think about the topic.
Thank you very much, Salah, for those insightful ideas. I think we don't have that much time to go further, so maybe we jump to the prizes, okay? So now, of course, we celebrate the spirit of scientific curiosity and innovation. Of course, all the presentations that have been done were, I mean, solid presentations and all, but we would like to get those that stood out by the clarity, good explanation, innovation, and all. So for that, we made the choice of two, one oral presentation as the best presentation, and one poster presentation as the best presentation. So for that, I will announce the presentation. I will take in charge of the oral presentation, and Professor Walid from Cairo University will take in charge the poster presentation. So could you join me, Professor Walid, por favor? Por favor. I don't know why I got por favor. I don't know Spanish. I will announce the all, and you will answer the poster. Okay. Okay. I will answer the winner for the all presentation, and you answer the. Okay. Let's start with the all. So the winner of the all presentation is Mrs. Hanal Idavisi. Congratulations. So this is the name.
All right. So the winner for the poster presentation, Mrs. Salma Bakhshou.
I have to make a note. So please just a moment to make concluding remarks and we leave. C'est vrai là. Ça fait. This is mine, yeah. شكرا. So we reached the end of the 2 first days of our North Africa workshop, regional workshop 2025. During those 2 days, we got many scientists and students that presented their work. I think it was very interesting to hear to all those subjects. And I think those presentations reflect how much Africa is moving ahead. And we hope that AfricaBP could push more and more the science in Africa, because it's true that we are working more in genomics and biology, but I think in examples such AfricaBP is able to push ahead many, many things. I think the science is heavily linked to the policy, to the economy, to the development of the countries. And by organizing such workshops, we are sure that somehow we are pushing the science and the economy and the development on the African populations. We hope to do more in the future. And to conclude, I would like to thank you all, really, every participant who traveled from far and near to come here and to promote this workshop. I'm really grateful. I would like to thank all the people that worked hard on that. Really, I have in mind one person, like always, which is Ishraq Hayah. She did a lot on that, really. I mean, more than when I can thank her. Thank you. I would like to thank all the organizers of AfricaBP. Thank God the founder of AfricaBP is with us, Julian, and all the people that are not present with us. Thank you to you all, and hope to see you the next year. We have 3 days more of the trainings, so for the participants, that's thank you.